Okay, so hello and welcome. We're here again. I realized that I am very good at procrastinating, and like it's pretty late already in the day. Like the day is like over already, and here I am starting my my work. I don't know what I did today, quite frankly. I think I wanted to watch a lot of things online. I don't know, man. I like to keep up with stuff online, and it's maybe not the best thing. Yeah, but what I can do is actually I need to. Oh shoot! I should respond to my friend here. Sorry, hold on a second. I'm trying to figure out. I want to set a timer for like how long we're gonna go for. I want to say like 5 hours. Let's say. I'll try to do that. Yeah. All right, we'll do 5. So it's like 10:30 Eastern, which is actually 9:30 my time. That's fine. All right, let's do that. Yeah, I'm very late. I don't even know what I did today. I think I watched some things online, listened to what people had to say, commented on some things, which I like to do that. I like to yeah, and didn't read my Bible. I did listen to some people who had things to say about Christianity, just things going on and things worth bringing up and talking about, and then I don't know, man, dude. I waste a lot of time. Or I'm like not as organized as I should be, because like I need to be coding things. I responded to a lot of emails too. I'm just trying to figure out like where did the time go, like what happened. Had food, I woke up late, responded to emails, responded to comments, watched the videos. I mean, I kind of got up like 11 o'clock or 10 o'clock, something like that. So that's still like 7 hours ago, 6 hours ago. So anyway, all right. So here we are. Let's get to the interesting part, which is let me just make sure there's anything I need to close before we start. Sometimes I leave things open that are kind of, let's just call it sensitive. All right. So, okay. Java annotation can be, right, we talked about this the other day. Yeah, Java annotation can be used to define the metadata of a Java class or class element. We can use Java annotation at the compile time to instruct the compiler about the build process. Annotation is also used at runtime to get insight into the properties of class elements. Java annotation can be added to an element in the following way: entity, class, demo, class. You can also set a value to the annotation member, for example, at entity name equals demo class. Interesting. Java, there are several built-in annotations. You can also define your own annotations in this way, the following way: target, element type method, retention policy runtime, interface, family budget, string, user role, default, guest. Okay, so this is kind of new to me, annotations. I've vaguely seen them before. I really don't use them very much. And I think, I want to say Spring Boot uses annotations quite a bit. Here we define an annotation, family budget, where user role is the only member in that custom annotation. The user role takes only string type values, and the default is guest. If we do not define the value for this annotation member, then it takes the default. By using target, we can specify where our annotation can be used. So method, I'm not sure what retention means. For example, the family budget annotation can only be used with the method in a class. Family budget annotation can only be used with the method in a class. Retention defines whether the annotation is available at runtime. Oh, interesting. To learn more about Java annotations, you can read the tutorial in the Java and the Oracle docs. Yeah, we should. Why not? Take a look at the following code segment. Target, element type method. So this kind of makes me think of the preprocessor for C++. Like you have in Java and C++ kind of have a lot of like overlap in their features, in that like you have generics in Java, you also have template programming in C++, you have a preprocessor in C++, like what they call the macros, preprocessor macros in Java. I guess it would be the annotations would serve as like preprocessor macros. or similarity to those things, which I don't really know. I don't really know much about either of them, quite frankly, but I guess we'll learn some of that now. We'll learn some of that now. So we have a target for the methods. We have retention, so it's available at runtime. Which again, I'm not entirely sure I understand what that means, to be available at what it means to be available at runtime, as opposed to being available at a different time. It clearly doesn't, right? It doesn't have anything to do with like where you would specify this when you're writing the code. It has something to do with when the code is actually running or compiling, potentially, I guess. Family member, senior member, int budget, money, spend. Senior member, spend, budget left. Okay, so senior member is going to spend from some budget. And then you have a junior user, has a budget, money, spend. Junior member, spend the amount of money. Budget left, budget money is the amount spent. So you have a junior user, senior member, family member, class solution, main, scanner in, test cases, integer, parse in dot next line. So that's interesting. I think the next line would be that's just kind of interesting. I guess yeah, each int is on another line. That's what that means. You have a role. You're spending a certain amount. You create. So you have an annotated class, family member.class. So that's interesting. Class variable. And okay, that's super interesting. Annotated class.get methods. Right, so these are all, I guess you'd have to use reflection, the reflection library for each method. Annotation present, family budget.class. It's this one. If the family budget method, family equals method.get annotation. So if you have an annotation for this method in the methods of this family member class, then you're going to get that annotation object as an object, and family budget.class get annotation for that method. That's kind of interesting. That the method is going to, you call the get annotation for this method. You also need to give the class variable. It's a little bit of a strange way of doing things. I don't know. Maybe I just don't understand how they built it. But I would kind of expect that you would just have method get annotation. Oh, I see. Family budget is actually the annotation. I see. No, that makes sense. I get it. I get it now. It says dot class, so actually family budget is itself. I guess that's how you access that annotation. I understand now. No, I get it. That makes a lot of sense. So you're actually specifying the annotation here. And then user role, family.user role, which is, oh, interesting. Yeah. That is the annotation. So you can get the annotation string, which the default is guest. And then you can get your budget limit, which is not actually part of the annotation, it looks like, which is kind of interesting. You have to add that, I guess. And if the user role is a certain role, then if your spending is less than the budget limit, then you invoke this method. Excuse me. Then you invoke this method with a new instance of our family member with the budget limit and the amount you're spending. We're going to spend. This is really interesting. By the way, I'm like trying to understand what the code does, because they said, hey, look, we have this code here. So presumably we need to know what it does. And then, so if your spending is less than the budget limit, then you're going to call so you're going to create a new instance of this class and invoke this method on this, with this instance and also with these parameters. So that's really interesting. I guess that makes sense. Yeah, I mean the method is part of that class, and so you create the new instance of that class, and then you give the parameters to the method. I have to look at this function signature for invoke, but I guess that's what's going on there. And then finally, if you're over the limit. So if the spending is less than the budget limit, and the budget limit comes from the annotation, then you can, if it's less, then you're going to call this. This will come out with this sort of, what do you call that? The text will kind of be printed, and then otherwise you say that you're over the limit. So this is for, and that's for every method. We do this. Every method that has this annotation, we find our information about our annotation, and then we check what's spent with respect to what's in that annotation, and then either print that we spent it or print that we're over the limit. And that's for every method in the family member class. So for each member, you'll get one of these calls happening. Otherwise, we have an exception, right? We just try this, so there could be all kinds of exceptions happen. I think this won't compile because this .budget limit doesn't exist in the in this annotation, at least not yet. So that should print stack trace, and you do this for each test case. It's interesting. This is not using the goes to operator, which is the minus greater than symbol. Looks like an arrow. Not making use of the goes to operator. What a mistake. What a mistake. All right. So here we partially define an annotation family budget and a class family member. Partially define an annotation family budget and a class family member. In this problem, we give the user role and the amount of money that the user spends as inputs. Based on the user role, you have to call the appropriate method in the family member class. If the amount of money spent is over the budget limit for that user role, it prints budget limit over. Now, something to note, after you spend this money, the budget limit doesn't change on the annotation. So like you could actually spend, like you can call this spend function a whole bunch of times with a bunch of different amounts, and the problem is, yeah, well, that's kind of tricky, huh? Oh yeah, that makes sense. I see. Yeah. Okay, I get it. Yeah, you're actually passing the budget limit here, but this budget doesn't change. Is my point. It says budget left, but each time you call this, it's going to give you, like if you repeatedly call, if you have multiple test cases and multiple amounts that they spend for those roles, then each time the budget in the annotation will basically sort of be reset, right? Presumably you set this budget limit once. Actually at compile time, when you're writing the code, actually is where you set that amount. It's also not there, by the way, in this piece of code, so it's not not even there yet. Probably they're going to ask us to fix it or change it. It's a pretty interesting question. I like this. It's kind of explore annotations and reflection and all that. Just see in the code, and down here you should have reflect and end annotation. Yeah, nice. Okay. Task is to complete the family budget annotation and the family member class so that the solution class works perfectly with the defined constraints. Okay, that's what there you go. Amount of money spent is over the budget limit. If that user prints budget limit over. Must complete the 5 incomplete lines in the editor. You're not allowed to change, delete, or modify any other lines. Restore the original code. Click on the top left button on the editor and create a new buffer. In the first line of input contains an integer n representing the total number of test cases. The first line of input contains an integer n representing the total number of test cases. Each test case contains a string and an integer separated by each test case contains a string and an integer separated by a space on a single line in the following format. So user role, money spent. Okay. So each test, okay. And yeah, so just roll next. Yeah, okay, that's fine. And 10, money spent between 0 and 200. Roll is 6. Name contains only lowercase English letters. Based on the user role and budget outputs, output the contents of the certain method. If the amount of money spent is over the budget limit, then output budget limit over. So 3, senior, junior, senior. Senior member spend, budget left 25, junior member spend, budget left 5, senior member 40, budget left 60. So it looks like the senior member is supposed to have 100 for the annotation, and the junior member is supposed to have 50 for the annotation. Okay, complete the interface. So this part should be int, and it's going to be budget limit, default 100. Yeah, let's go 50 actually. Doesn't really matter what the default is actually in this case. Well, I mean, they already, okay. All right. Hopefully that's correct. Yeah, we may need to refresh this. Complete this line. So we're gonna have our @family budget, and we're going to set the user role is going to be equal to senior, and the budget limit is going to be 100. Now I don't know if we can do it that way. We could try. And the junior is going to be 50, and the user role is junior. Pretty interesting. Oh, complete this line. Well, kind of already gave us those lines. Neck. Let's see if this compiles. Oh, it's correct. Sweet. Sweet. See what happens when we run it, submit it. Hey, it worked. Okay, nice. That's fun. Yeah, I like that. That's pretty good. That's pretty good. Super interesting. The number of user roles is 6. I don't think that's correct. Yeah, where did that constraint come from? I don't know what that is. Oh, the size of the user role is 6? Oh, I see. In other words, the name size. I mean, that's okay, I guess. That's like, there's only 2. Alright. I don't know. I guess you could throw that in there too. Why not? It's not very meaningful, but okay, neat. I like this problem. It's good. Good to learn a little bit about Java annotations. Fun. How long did that take? Yeah, 18 minutes. Okay. All right, now I know what annotations do. I mean, I don't think these are like preprocessor directives. That's not really what these are. We should read about this though, definitely. Excuse me, and learn more. Annotations, a form of metadata, provide data about a program that's not part of the program itself. Annotations have no direct effect on the operation of the code they annotate. Well, unless you use reflection to do that. Annotations have a number of uses, among them information for the compiler. Can be used by the compiler to detect errors or suppress warnings. Compile time and deployment time processing. Software tools can process annotation information to generate code, XML files, and so forth. So yeah, this is kind of like pre-processing and runtime processing. Some annotations are available to be examined at runtime. This lesson explains where annotations can be used, how to apply annotations, what predefined annotation types are available on the platform. The Java platform, standard edition, Java SE API, how type annotations can be used in conjunction with pluggable type systems. Type annotations can be used in conjunction with pluggable type systems. How type annotations can be used in conjunction with pluggable type systems to write code with stronger type checking. Not sure what that means exactly. And how to implement repeating annotations. And then you have repeating annotations. Okay, I don't know what all those things are. It's all new to me. The basics. So there are improvements and might use things no longer available. Okay. Interesting. Alrighty, so Annotations Basics. The format of an annotation in its simplest form, an annotation looks like the following. At entity, the @ sign character indicates to the compiler that what follows is an annotation. In the following example, the annotation's name is override. Annotation can include elements, which can be named or unnamed, and there are values for those elements. At author, oh, I see. Okay, with commas. Yeah, that's how I did it before. Can include elements, my class, or suppress warnings, value equals unchecked. If there is just one element named value, the name can be omitted, as in unchecked. If the annotation has no elements, then the parentheses can be omitted, as shown in the previous override example. Also possible to use multiple annotations on the same declaration. Name, Jane Doe, ebook, my class. If the annotations have the same type, then this is called a repeating annotation. Oh, okay, I see. So you can annotate more than once. Repeating annotations are supported as of the Java SE 8 release. For more information, see repeating annotations. Annotation type can be one of the types that are defined in the java.lang or java.lang.annotation packages of the Java SE API. In the previous examples, override and suppress warnings are predefined Java annotations. Override and suppress warnings are predefined Java annotations. It is also possible to define your own annotation type. The author and ebook annotation in the previous example are custom annotation types, where annotations can be used. So I think we can define an annotation with an @interface annotation, and then we can give it a name, and then specify annotation variables from there. Annotations can be used. Annotations can be applied to declarations. Declarations of classes, fields, methods, and other program elements. When used on a declaration, each annotation often appears by convention on its own line. As of the Java SE 8 release, annotations can also be applied to the use of types. Here are some examples. So class instance creation expression, interned my object, type cast, non-null string, implements clause, class implements read only, thrown exception declaration, monitor temperature throws at critical, temperature exception. This form of annotation is called a type annotation. For more information, see type annotations and pluggable type systems. Declaring annotation type. So this is probably kind of involved, this whole thing. Declaring an annotation type. Many annotations replace comments in code. Suppose that a software group traditionally starts the body of every class with comments providing important information. So we have generation 3 list, extends generation 2 list, John Doe, date, current revision, last modified, Jane Doe, reviewers. Class code goes here. To add the same metadata with an annotation, you might define the annotation type. Syntax for doing this is class preamble, author, date, current revision, last modified by, use of array, reviewers. The annotation type definition looks similar to an interface definition, where the keyword interface is preceded by the @ sign. Is as in annotation type. Annotation types are a form of interface, which will be covered in a later lesson. For the moment, you do not need to understand interfaces. The body of the previous annotation definition contains annotation type element declarations, which look a lot like methods. Note that they can define optional values. After the annotation type is defined, you can use annotations of that type. The values filled in like this: class preamble, author, date, revision, last modified by, and then array, reviewers, Alice, Bob, Cindy. Public class generation, class code goes here. To make the information in the class preamble appear in Javadoc generated documentation, you must annotate the class preamble definition with the documented annotation. Import this to use at documented interface. Oh, interesting. So you can annotate your annotations to make it a documentation annotation. That's really interesting. Yeah, Javadocs. I kind of So this is really good. Javadoc generated documentation is phenomenal. Kind of wonder if there's something similar for other. I know there's Doxygen I've heard of, which I think is also useful for documenting your code. I don't know, like for other languages as well as like C++ in particular. I kind of wonder what they use, what's normally used to like generate documentation. What am I looking for? Oh yeah, time. Yeah, okay. Yes, annotations, not really a small thing, I guess. Or it's kind of, I mean, it seems like a small thing, but it's kind of involved. Predefined annotation types. A set of annotation types are predefined in the Java SE API. Some annotation types are used by the Java compiler, and some apply to other annotations. Predefined annotation types. A set of annotation types are predefined in the Java SE API. Some annotation types are used by the Java compiler, and some apply to other annotations. Annotation types used by the Java language. The predefined annotation types defined in java.lang are deprecated, override, and suppress warnings. Deprecated annotation indicates that it's funny, I'm reading this now, like my whole life up to this point, whenever I would see annotations in Java code, I would just ignore it. Like I always just kind of always see it and wonder what does that mean? What is that? And like, don't worry about it. Now's not the time to worry about that. And now here we are, and I'm finally looking at it. It's like, I wish I'd read this sooner. Just because every time I would see these things, I wouldn't, because like my mind habitually, I'm just like immediately ignoring. Like I'm actually literally looking at them, and I'm just reminding myself not to bother with what these mean. And I was like just now I had that experience of like, why are you doing that? Like you can read what it means right here. Like now you finally know what these things mean, and you don't have to, basically guess what they mean and assume what they mean, because that's kind of like, also sort of just in my life, I've been sort of like, things just get thrown at me so chaotically and in such, like basically I always find myself in this position of like, I'm expected to do something that I don't know how to do, and I have to basically guess what the meaning is. Like without documentation, without prior knowledge, without pretty much I'm just expected to figure out how something works in short order without like really very much help or documentation or like knowledge of it or anything like that. Just kind of like basically do your best to try to figure out the context and effectively wing it. And I've been expected to do that so much in my life, particularly around programming. And I was like, I'm thinking about it now, and like this is one of those things that just finally I could just sit down and learn, and sit down and understand what I'm looking at. But yeah, I actually literally have like a habit now of like when I see these annotations, I just ignore them as something I don't know what they are, what they do, and I don't need to know. So just don't worry about it. But I'm looking at it now, and I'm like, no. It's time to learn what those things mean. Those things that you've been ignoring for years. You can finally look at them. Oh boy, that's astounding. Anyway, okay, so it's annotation types used by the Java language. The predefined annotation types defined in java.lang are deprecated, override, and suppress warnings. All right, so deprecated annotation indicates that the marked element is deprecated, should no longer be used. The compiler generates a warning whenever a program uses a method, class, or field with the @deprecated annotation. When an element is deprecated, it should also be documented using the Javadoc @deprecated tag, as shown in the example. The use of the sign in both Javadoc comments and in annotations is not coincidental. They are related conceptually. Also note the Javadoc tag starts with a lowercase d and the annotation starts with it. So I also do need to learn about Javadocs too. I kind of know what Javadoc comments do, but they also have annotations. Explanation why it was deprecated. Override. So Javadocs also similarly fall in that category of like things that I vaguely know what they do, but I really don't, and I have to like go read the documentation to know what it means, what these things are. Override. Override annotation informs the compiler that the element is meant to override an element declared in a superclass. Overriding methods will be discussed in interfaces and heard. So yeah, we kind of looked at that briefly already. mark method as a superclass method that has been overridden. Overridden method. Yeah, so, okay. While it's not required to use this annotation when overriding a method, it helps prevent errors. If a method is marked with an @override, fails to correctly override a method in one of its superclasses, the compiler generates an error. Yeah, that's a good idea. So I would do that, because if you don't do that, then the problem you run into is you might think you overrode an error or overrode a function, but you didn't. So then in your code later, because it's not overridden, and when you use that function, it's going to use the superclass function instead of the override, and then you're going to be very confused. That's what's going on in your function, your code, why there are errors and things, and that can be very subtle. The differences too. I personally, I don't think it's a good idea to override methods at all. My opinion, unless they're totally abstract. And the reason is that when it's list-conf substitution is the idea. So anywhere that you could use an object A, you also should be able to just as easily use object B, where B is a subclass of A. That's the idea, and you have a problem if you override a method of A. Obviously, you've changed the idea is to not change the functionality that is inherited from A. So all of that functionality is, so anywhere you could use A, you could also use B, because all that functionality is the same for B as well as for A. But if you override a method, that actually directly breaks list-conf substitution. So yeah, and that gives you code maintainability and extendability issues. Okay, so suppress warnings. Annotation tells the compiler to suppress specific warnings that it would otherwise generate. In the following example, a deprecated method is used, and the compiler usually generates a warning. In this case, however, the annotation causes the warning to be suppressed. So we can use a deprecated method and tell the compiler not to generate a warning. Suppress warnings deprecation. Use deprecated method. Deprecation warning suppressed. Deprecated method. Every compiler warning belongs to a category. The Java language specification lists two categories, deprecation and unchecked. The unchecked warning can occur when interfacing with legacy code written before the advent of generics. To suppress multiple categories of warnings, use the following syntax. So it looks like there's only two categories for warnings: deprecation warnings and unchecked warnings, which are when you have legacy code written before the advent of generics. That's interesting. I don't know what that is. Suppress multiple categories of warnings, use the following syntax. What is the unchecked warning? What does that even mean? I don't know, I wouldn't worry about it. So, okay. Safe var args annotation, when applied to a method or constructor, asserts that the code does not perform potentially unsafe operations on its var args parameter. When this annotation type is used, unchecked warnings relating to var args usage are suppressed. So there's variadic arguments. Okay, so the unchecked warnings related to the variable arguments usage is suppressed. Okay, interesting. Functional interface. This is actually also a suppression. Introduced in Java SE8 indicates that the type declaration is intended to be a functional interface as defined by the Java language specification. Functional interface annotation introduced in Java SE8 indicates that the type declaration is intended to be a functional interface. What does that mean? Let's actually read each of these, get more context. I don't know what it means to be a functional interface, but you can annotate it as a functional interface. I think I know what this is supposed to be, but it's also only Java 8, which I think all of the Hackerrank questions we've done so far were not Java 8, all the Java 7. Annotations that apply to other annotations. Annotations that apply to other annotations are called meta annotations. So we have meta annotations. There are several meta annotation types defined in Java.lang annotation. At retention annotation specifies how the marked annotation is stored. Okay. Retention policy.source, the marked annotation is retained only in the source level and is ignored by the compiler class. Marked annotation is retained by the compiler at compile time, but is ignored by the JVM. So the compiler doesn't even have this Okay, so source means the compiler won't even consider the annotation. Class means the compiler considers it, but it never makes it to runtime. And runtime means marked annotations retained by the JVM so that it can be used by the runtime environment. So you can actually, your annotation will actually be in the runtime in the JVM when your program is running. So you can use reflection to actually change the behavior of your program based off of the annotations. Interesting. Documented. Okay, so I get it now. Excuse me, I get it. That was what I was asking before. I was like, what's the difference? What are the other options? Documented annotation indicates that whenever the specified annotation is used, those elements should be documented using the Javadoc tool. By default, annotations are not included in Javadoc. For more information, see the Javadoc tools page. Yeah, we're gonna have to learn more about Javadoc too. That's a lot of reading, man. There's a lot of reading. Whenever the specified annotation is used, those elements should be documented using the Javadoc tool. Okay. Okay, I think I get it. At target annotation marks another annotation. So these are meta annotations. So this is for another annotation. Yeah, these are all for other annotations. So this denotes that another annotation should be used in the Javadoc tool. At target annotation marks another annotation to restrict what kind of Java elements the annotation can be applied to. So this is restriction. Okay, target annotation specifies one of the following element types as its value. So it can be annotation type, can be applied to annotation type. So this is a meta, is only for meta annotations, right? They can only be applied to other annotations. It can only be applied to constructors, other fields, or constructors, fields, local variables, methods, packages, parameters, and types. Declarations, right? Applied to any element of a class. Any element of a class. I'm not sure if that just means like anything. Can apply to the parameters of a method. Oh, that's interesting. Parameters of a method. Okay. A package declaration. Method level annotation. So methods, packages, parameters, local variables. Oh, wow. You can annotate a local variable. Imagine that. Field can only be applied to a field or property, which I think these are, fields are like the member variables basically. Yeah, field, they're called fields. Also, or member variables, and then constructors. Okay, wow. But you can annotate any of these things, right? And I guess this is basically everything. Inherited annotation indicates that the annotation type can be inherited from the superclass. This is not true by default. Inherited annotation indicates that the annotation type can be inherited from the superclass. I don't really know what that means. When the user queries the annotation type and the class has no annotation for this type. When the user queries the annotation type and the class has no annotation for this type. When the user queries the annotation type, when the user queries the annotation type and the class has no annotation for this type. When the user queries the annotation type and the class has no annotation for this type. The user queries the annotation type and the class has no annotation for this type. I'm not sure what that means. I don't know what it means to query an annotation type. The class's superclass is queried for the annotation type. This annotation applies only to class declarations. Yeah, that's really confusing. So this is a meta annotation that indicates that the annotation that it's a meta annotation for can be inherited from the superclass. Okay, so if there's an annotation on a class and then there's a subclass, that subclass will then inherit that annotation if that's an inherited annotation. Okay, it's really confusing, but I get it. This is not true by default. Got it. When the user queries the annotation type and the class has no annotation for this type, so presumably using the reflection library to do that, perform those queries. The class superclass is queried for the annotation type. Gotcha. This annotation applies only to class declarations. Interesting. It really, actually, its annotation applies to only to annotations annotation applies only to class declaration annotations. I think it's actually, maybe they need to rephrase this, because this is a meta annotation on other annotations that apply to class declarations. I guess that's what they mean. This is an annotation you can only apply to a class declaration, which is really an annotation on an annotation for a class declaration. Meta. No, I guess not that meta, but just one layer up. Okay, at repeatable annotation introduced in Java SE8 indicates that the marked annotation can be applied more than once the same declaration or type use, and we kind of went over repeating annotations before, but we'll look at it. I think we have it twice now. We have 2 of these. It's repeated. So what else do we have here? Repeatable indicates the marked annotation can be applied more than once, the same declaration or type use. Yeah, okay, interesting. Okay, so that's meta annotations, and you can have user-defined annotations. Okay, so there's only 3 annotations provided, 5 annotations provided by the Java language, and all the other annotations are either user-defined or they're meta annotations, which you have 1, 2, 3, 4, 5 meta. So there's 5 annotations and 5 meta annotations, and you can define your own annotations. Oh man. Okay, I can see why I would be ignoring these most of the time though, because they don't seem to be too significant overall. Feels like you could probably get by without really knowing very much about annotations. Now, I think what is interesting about that though is that, like I said, I think the Javadocs use annotations quite a bit apparently, and the Java Spring, like Spring Boot and Java Spring, I think they use annotations to like configure the different components that you're going to use on your backend when you build with Java Spring and Java Boot, or Spring and Spring Boot. All right, type annotations and pluggable type systems. Type annotations and pluggable type systems. Before the Java SE8 release, annotations can only be applied to declarations. As of the Java SE8 release, annotations can also be applied to any type use. This means that annotations can be used anywhere you use a type. A few examples of where types are used are class instance creation expressions, new casts, implements, clauses, and throws clauses. Form annotations called a type annotation. Several examples provide Annotations Basics. Okay. Also, I think I want to stand up because I'm kind of just gonna stand up and kind of bend over because something's going on with my my body and it's not comfortable. I don't know what it is, but it's got me kind of like, I feel like maybe I should stand. That might help, whatever it is. Yeah, so I guess we'll do it this way. It's probably not the best way to do it, but we can do it like this, I suppose. Yeah, not ideal, but I guess we're doing that. So, what else do I want to say here? So how are we doing on time? Yeah, 40 minutes. Okay. Wow, look at all these pages to read. Okay, type annotations and pluggable type systems. Before the Java SE release, annotations could only be applied to declarations. As of the Java SE8 release, annotations can also be applied to any type use. This means that annotations can be used anywhere you use a type. Excuse me. A few examples of where types are used are class instance creation expressions, new casts, implements clauses, and throws clauses. Okay, gotcha. This form annotation is called a type annotation, and several examples are provided in Annotations Basics. I think we just looked at that before, right? Yeah, so we saw that, some examples. So a cast, when you create a new object, when you implement an interface, or I think implement for interfaces, and then when you throw an exception even as well. You can use it in all of these cases. That's what they were described before, so that's good. Type annotations were created to support improved analysis of Java programs way Supports improved analysis of Java programs way. I don't know, this English is kind of. All right, that's okay. Java programs way of ensuring stronger type checking. I don't know how this English is correct. Is it of Java's way or Java programs way? I think there's missing an asterisk here or something. I don't know. The Java SE8 release does not provide a type checking framework, but it allows you to write or download a type checking framework that is implemented as one or more pluggable modules that are used in conjunction with the Java compiler. So okay, so we're saying that we have support improved analysis of Java programs such that stronger type checking can be ensured. The Java SE8 release does not provide a type checking framework, but it allows you to write or download a type checking framework that is implemented as one or more pluggable modules that are used in conjunction with the Java compiler. Okay, for example, you want to ensure that a particular variable in your program is never assigned to null. You want to avoid triggering a null pointer exception. You can write a custom plugin to check for this. You would then modify your code to annotate that particular variable, indicating that it's never assigned to null. The variable declaration might look like this. Non-null string. So what's interesting about Java and C++ is that Java is always using references, the objects. They're passed by reference. Everything's just passed by reference. You never actually create like new objects and new variables for your parameters. So everything's passed by reference. But what's interesting is when you call a function with a particular variable, C++, the default behavior is actually create a new instance of that particular variable basically use it's almost like a copy constructor kind of a thing. Whereas C++, you could change that behavior by using a reference sigil, we'll call it. Symbol, reference symbol, and then usually it's the asterisk symbol, and then if you do that, then that's more like Java's behavior. But what's really interesting about that is actually Java and C++ are sort of distinct from each other in that regard, because C++, even though you can pass by reference by actually specifying, that's actually what happens, right? When you use that sigil, is it says you pass by reference instead of pass by value for that particular variable. The difference is you can't actually set any of the references to a null pointer. Like you can't point it to null. Because references are basically like aliases. So the alias itself, you cannot set it to null. You could set the how does it work? Pointers can be set to null pointers, but you can't actually set. I don't know. Can you do that in C++? I'm trying to think if you can set a reference to point to something that's a null. I don't think you can. You can maybe have a reference to a pointer. Or pointer reference rather. Yeah, and then set that to a null pointer, but that's not really what we're talking about. We're talking about like objects themselves, the references themselves. Whereas in Java, you can actually set an object directly to null, which is a bit of a excuse me. I actually remember in university when I was learning about these things, 10 years ago, whatever it is. I remember being really confused by those things, like really confused that you can set pointers to null pointers in C++, and you can set objects in Java, variables that point to an object, to null also, but you can't set a reference in C++ to a null pointer, to null, which is very interesting, kind of a very subtle difference between the two. Because I remember like there was some scenario I was looking at where I was like, oh, like how do I set this object to null? It's like you can't do that. Excuse me, in C++, but you can in Java, because I was going between Java and C++ in my classes. So yeah, that's a very slight, subtle thing, but yeah, so they're not exactly references in Java, because you can set them to, they're not aliases. They're references, but they're not aliases. That you can't set them to null, or rather you can set them to null, but you can't do that in C++. So yeah, it works slightly differently. Very interesting though, very interesting. So for example, you want to ensure that a particular variable in your program is never assigned to null. You want to avoid triggering a null pointer exception. You can write a custom plugin to check for this. You would then modify your code to annotate that particular variable, indicating that it is never assigned to null. The variable declaration might look like this: at non-null string. When you compile the code, including the non-null module at the command line, the compiler prints a warning if it detects a potential problem, allowing you to modify the code to avoid the error. After you correct the code to remove all warnings, this particular error will not occur when the program runs. You can use multiple type checking modules where each module checks for a different kind of error, and this way you can build on top of the Java type system, adding specific checks when and where you want them. With the judicious use of type annotations and the presence of pluggable type checkers, you can write code that is stronger and less prone to error. Interesting. In many cases, you do not have to write your own type checking modules. There are third parties who have done the work for you. For example, you might want to take advantage of the checker framework created by the University of Washington. This framework includes a non-null module, as well as a regular expression module, and a mutex lock module. For more information, see the checker framework. Okay, interesting. Neat. So you can use a pluggable type checking system that someone else made, third-party system, that allows you to add certain annotations to your code to make things a little bit more bug-free, I guess. Yeah, very interesting. Tired of null pointer exceptions, unintended side effects, SQL injections, concurrency errors, mistaken equality tests, other runtime errors that appear during testing or in the field? The checker framework enhances Java's type system to make it more powerful and useful. This lets software developers detect and prevent errors in their Java programs. Checker framework includes compiler plugins checkers that find bugs or verify their absence. It also permits you to write your own compiler plugins as well. Oh, that's very interesting. Wow. Quick start, installation instructions tutorial, checker framework zip, instructions tutorial, documentation, September 1st, 2021. Okay, so this is pretty recent, the updates. So they're pretty good about keeping it updated. Documentation, framework manual, installation instructions, tutorial, FAQ, nullness checker tutorial, Javadoc API documentation, FAQ, changelog, source code repo at GitHub. Framework manual contains instruction on building from source. Developer manual, interface, inference tools. Inference tools automatically add annotations to your code, making it even easier to start using the checkers. Oh, that's interesting. So we have inference tools. Whoa. Optional related tools. The annotation. So optional. So inference tools. The optional related tools. The annotation file utilities extract annotations from and write annotations to .java and .class files. Also provides a representation called an annotation file for annotations that is outside the source code or the .class file. The tools support both Java 5 declaration annotations and Java 8 type annotations. So there's annotation file utilities, and then you have the archive of previous releases in the checker framework of the checker framework, and then research papers. See the checker framework manual. Supporting community. Oh wow. Yeah, lots of documentation. Bug reports, mailing lists. That's pretty interesting. Updated in 2021. So I wonder how old this is. Type inference tools. Tools. So wow, look at how much there is to read here. Contents, right? Here's like the manual. Whoa, this is such a large manual. So much here. 39 chapters on the checker system. Whoa. Whoa. How to read this manual, how it works, pluggable types, installation, Wow, that is like no small thing, right? Pretty interesting that this is like so involved, you know. I wonder if they have these things for C++, lock checker, index checker for sequence bounds, regex checkers, format string checker, internationalization, format string checker, property file checker, signature, string checker, GUI effect checker, units checker, signedness checker, purity checker, constant value checker, turns receiver checker, reflection resolution, initialized fields checker, aliasing checker. I didn't know they had aliasing in Java. I was trying to do some form of aliasing before. I guess you do have something for aliasing. Must call checker, subtyping checker, third-party checkers. So there's other checkers, I guess. Oh, other programs, I guess. Yeah, okay, interesting. Generics and polymorphism, advanced type system features, suppressing warnings, type inference, annotating libraries, how to create a new checker, building an accumulation checker, integration with external tools. Wow. Frequently asked questions, troubleshooting, getting help and contributions. Wow. Wow. Whoa. We just got 40 chapters of reading to do. If we really want to use this, properly use this. Oh boy, that is quite the commitment in terms of time. Wow. Okay. No kidding. Type inference tools. This section lists tools that take a program and output a set of annotations for it. It first lists tools that work only for a single type system, but may do a more accurate job for that type system. That then lists general tools that work for any type system. Nullness checker, the several tools then for annotation of the nullness checker. Purity checker, you run the checker framework with the suggest pure methods command line option. It will suggest methods that can be marked as side effect free, deterministic, or pure. WPI for any type system, whole program inference, or WPI is distributed with the checker framework. Whole program inference. Interesting. I don't really know what that does. I'll read that in a moment. CFI for any type system, checker framework inference, or CFI is a type inference framework built on a variant of the checker framework. You need to slightly rewrite your type system to work with CFI. CFI repository contains rewritten versions of some of the type systems that are distributed with the checker framework. Okay. I don't know what that does either. I guess you have to read these two sections to understand that. Cascade for any type system. Cascade is an Eclipse plugin that implements interactive type qualifier inference. What does that mean? Cascade is interactive rather than fully automated. It makes it easier for a developer to insert annotations. Cascade starts with an unannotated program and runs a type checker. For each warning, it suggests multiple fixes. The developer chooses a fix, and Cascade applies it. Cascade works with any checker built on the checker framework. You can find installation instructions in a video tutorial. Cascade was last updated in 2014. Might or might not work for you. Wow, 7 years ago. Except for one of the nullness inference tools, all these type inference tools are static analyses. They analyze your program's source code, but they do not run your program. Okay. Interesting. So there's different static analysis tools you can use, or you can use different type inference tools to make setting up your type inference program easier, and then the type inference, or setting up your type inference framework easier, and your type inference framework is going to annotate your code, and when you compile your code, it uses this framework to ensure that certain runtime errors are avoided by throwing compile time warnings, and then you can use those annotations with the compile time warnings to avoid runtime errors later. Yeah, that's so confusing, but I get it. So there are certain errors at runtime you're trying to avoid. So in order to avoid them, you're going to introduce potential compile time errors through the annotations in Java, and you can use basically it's like a preprocessor with your compiler that will use those annotations to then look for potential compile time errors based off of the annotations you've written. And then if you rewrite your program to adhere to those compile time errors and those annotations, then presumably you will avoid those runtime errors. Got it. Really complicated. But basically this makes your code more bug-free. Bottom line is avoids bugs in your code. This is pretty good. I think this is something worth investing the time into if you're going to write Java code seriously. However, wow, that's a lot of extra learning, you know? That's a lot to learn to implement all of that. But, I mean, it's good. I mean, it is what it is, right? It's good. It's, you know, you want to put that time in, make things a little bit more secure. Why not? Whole program inference. Whole program inference infers types for fields, method parameters, and method return types that do not have a user-written qualifier for the given type system. The inferred type qualifiers are output into annotation fields. The inferred type is the most specific type that is compatible with all the uses in the program. Oh, that's interesting. For example, the inferred type for a field is the least upper bound of the types of all the expressions that are assigned into the field. There are 3 scripts that you can use to run whole program inference. Each has advantages and disadvantages discussed below. Run whole program inference on a single project without modifying its source code. Use the wpi.sh script, section 33.3. This script can automatically understand many Ant, Maven, and Gradle build files, so it requires little manual configuration to run whole program inference on many projects without modifying their source code. Say when running it on projects from GitHub, use the WPI many shell script. This script can understand the same build files as WPI sh. If you want to insert the inferred annotations directly into a single project source code, use the infer and annotate script. Interesting. These type inference scripts appear in the checker bin directory. The remainder of this chapter describes them, then concludes with the discussion that applies to all of them. So there's more explanation of what these scripts do. But yeah, you can. So whole program interface inference infers types for fields, method parameters, and method return types that do not have a user-written qualifier for the given type system. Okay, I'm not really sure what that means. The inferred type qualifiers are output into annotation files. So we have an annotation file. Okay. The inferred type is the most specific type that is compatible with all the uses in the program. I don't really understand. I think I would need to have like more examples to really understand what they're describing here, but that sounds good, I guess. Basically, it's automating adding annotations, I think. I think that's the idea. And then what's this? Checker framework interface. Type in inference framework built on a variant of the checker framework. Okay. You need to slightly rewrite your type system to work with CFI. CFI repository contains reversions of some. So you can do whole program inference, which is distributed with checker. You can do checker framework inference, which is a different framework built on top of. Oh, I'm sorry. Oh, I get it. Right. So inference is inferring these annotations automatically, and the CFI is built on a variant of the checker framework. I guess not exactly. And then there's one that's distributed with the checker framework. This is the whole program inference. There's another one that's an checker framework inference, which is I guess a variation of the WPI kind of a thing. I'm not exactly sure if it's interactive or not. I'm not really sure what it is. And then there's Cascade, which is an interactive type inference tool. So that'll help you annotate interactively rather than in an automated way. I think that's what's going on here. And there's these 2 other checkers that will automatically do nullness checks and another automatic purity checking for side effects. So purity meaning whether or not your function has side effects, your methods have side effects. Okay. Oh yeah, Java doesn't have functions, by the way. Java only has methods because everything in Java is within a class. So yeah. So if you want free functions, they're really just classes with single functions in them. I guess they'd be like static classes with methods. And then if you wanted if you wanted inline functions, you would have anonymous classes. Really, that's what they are, or just classes with a single function in them as an inner class of the single function. And I guess you'd make it like a private inner class or something. So that's interesting. I'm just realizing that now. So yeah, pretty involved. This we kind of went down quite a rabbit hole with annotations, but yeah, you can use annotations to use basically pre-processing. And Java, it seems to be for the most part, uses these for. Seems Java uses these mostly for, or at least it's been used. I think these annotations to do, to move runtime errors into compile time errors, using annotations and a preprocessor. It's effectively a preprocessor for the compiler. So that's pretty interesting. So yeah, I was kind of right that annotations have some preprocessing, although C++ uses preprocessing to actually like extend functionality, sort of, whereas Java doesn't really use it for that. So it's interesting because the preprocessing in Java, it seems to make your code actually less prone to errors, whereas in C++ it makes it more confusing and more prone to errors, because who knows what they've added in their macros. I mean, the macros are like totally custom user defined, so the macros they're sort of imbued with whatever meaning you want, whereas in Java it looks like they're using the macros actually not to introduce more code, but to annotate your code only, and then figure out, basically do type checking and checking for certain potential errors, which is very different. There's two very different things, adding kind of arbitrary meaning and code to your code in a programmatic way, somewhat programmatic way. It's not even that programmatic. It's just like, it really is just like inserts code into your inserts code into your source file through the preprocessor. It's really is just like code insertion. That's kind of what it is. It's just source code insertion. It's kind of pretty rudimentary. It's kind of like, I don't want to say barbaric's not the right word, but it's like kind of really raw. Like it's a very raw kind of a thing. Definitely very easy to cause a lot of confusion and errors. Yeah, raw is probably the right word. But anyway. Okay, so repeating annotations. There are some situations where you want to apply the same annotation to a declaration or type of use. As of the Java SE8 release, repeating annotations enable you to do this. For example, you are writing code to use a timer service that enables you to run a method at a given time or on a certain schedule, similar to the Unix cron service. Now you want to set a timer to run a method, do periodic cleanup on the last day of the month and on every Friday at 11 p.m. Set the timer to run, create an @schedule annotation, and apply it twice to the do periodic cleanup method. First specifies the last day of the month, and the second specifies Friday at 11 p.m. as shown in the following code example. Previous example applies an annotation to a method. You can repeat an annotation anywhere you would use a standard annotation. For example, you have a class for handling unauthorized access exceptions. You annotate the class with one @alert annotation for managers and another for admins. For compatibility reasons, repeating annotations are stored in a container annotation that is automatically generated by the Java compiler. In order for the compiler to do this, 2 declarations are required in your code. Oh, interesting. Declare a repeatable annotation type. The annotation type must be marked with the repeatable meta annotation. The following example defines a custom @schedule repeatable annotation type. Repeatable schedules.class interface schedule. Value of the repeatable meta annotation parentheses is the type of the container annotation that the Java compiler generates to store repeating annotations. In this example, the containing annotation type is schedules, so repeating @schedules annotations is stored in an @schedules annotation. Oh, okay, interesting. So schedules is the annotation, and then you'll have multiple @schedule annotations. Okay, so you can So you have to specify a containing annotation in using your meta annotation. Declare the containing annotation type. The containing annotation type must have a value element with an array type. The component type of the array type must be the repeatable annotation type. The declaration for the schedule's containing annotation type is the following. The containing annotation type must have a value element with an array type. Declare the you have to declare the containing annotation type too. Okay, interesting. Component type of the array type must be the repeatable annotation type. This declaration for the schedules containing annotation types. Excuse me. So this isn't automatically generated by the compiler or the preprocessor or what have you. I guess because Java doesn't really have a preprocessor, it just has a compiler. So unless you add a preprocessor, these things you have to add yourself. That's interesting. So you have to have a containing annotation, and so you have to specify that, and that has to have an array value. Interesting. Retrieving annotations, there are several methods available in the reflection API that can be used to retrieve annotations. The behavior of the method that returns a single annotation, such as annotated element.get annotation, are unchanged, in that they only return a single annotation if one annotation of the requested type is present. If more than one annotation of the requested type is present, you obtain them by first getting their container annotation. In this way, legacy code continues to work. Other methods were introduced in Java SE 8 that can scan through the class annotation to return multiple annotations at once, such as annotated element get annotations by type. See the annotated element class specification for information on all of the available methods. Yeah, okay, that was actually my next question is, how does the reflection library deal with this? Oh, that's how. It has a containing annotation that has an array of these, and then that gets returned. Okay, that's simple enough. I thought something like that would be how it would be done. Simple enough. Design considerations when designing an annotation type. You must consider the cardinality of annotations of that type. That is now possible to use an annotation 0 times once, or if the annotation's type is marked as repeatable more than once. It is also possible to restrict where an annotation type can be used by using the target meta annotation. For example, you can create a repeatable annotation type that can only be used on methods and fields. It is important to design your annotation type carefully to ensure that the programmer using the annotation finds it to be as flexible and powerful as possible. Wow, there's a lot going on here, man. This is like, whoa. It's just annotating your code. You have all this stuff going on. Yeah, wow, it's quite the thing. It's quite the thing, but neat. Questions and exercises. What is wrong with the following interface? Okay, sure. Public interface house deprecated. Deprecated's got to be at the top here. Yeah, if you want house to be deprecated, you want the annotation up here. Also, if you're deprecated, you want Javadoc deprecated. Also, unless this function that's deprecated, the method that's deprecated. I don't know if the method, if you annotate the method, I want to say the annotation is in the wrong spot, but the interface can be deprecated. I don't know if you can deprecate a single method. Let's see. What are the answers for one? Check your answers. Yeah. What does one say? Let's not go to 2. Just 1. Documentation should reflect why open is deprecated and what to use instead. Oh, okay, I was wrong. Yeah, I thought it. Yeah, it was either one or the other. Either it was the documentation, or was that it's the whole interface, not just the method. But I think it looks like you'd apply this to methods too. So, for example, why it's deprecated and what to use instead. Use of open is discouraged. Use front door or back door instead. Okay. So I was wrong. So you want to have a Javadoc for deprecated. Fair enough. 2. Consider this implementation of the house interface shown in question 1. So I was wrong. I was wrong. It was not. Yeah, you can deprecate methods, which actually makes a lot of sense. It really should be that way. Consider the implementation. Actually, I guess that makes sense. We were just saying that before. There aren't really functions. There's just methods. So the only thing you really can deprecate are methods, because those are the only things you can call. So you wouldn't deprecate an entire class. I guess you could deprecate an entire class, but presumably most of the time you'd be deprecating methods themselves. Implementation of the house interface shown in question 1. Public class my house implements house. We have open front to open backdoor. You compile this program, the compiler produces a warning because open was deprecated in the interface. What can you do to get rid of that warning? Well, you can use suppress warnings, and you can do the category. There's two categories of checked, unchecked, and what's the other one? I don't remember them offhand. Hold on, let's go back to predefined annotation types, suppress warnings, deprecation. That's it. Literally unchecked and deprecation. So you do unsuppress warnings as deprecation. Okay. You can add that. You can add that annotation. Now I think suppress warnings is an annotation, not a meta annotation. So you can add that annotation. If you compile this program, the compiler produces a warning because open was deprecated in the interface. What can you do to get rid of that warning? Right, suppress warnings annotation, and we're going to give it the we can give it two tags. We're just going to give it one, but it could be two. It could be unchecked as a string, and the other string is deprecation. It's actually the category of warning. There's only two though, and one of them is sort of legacy reasons. Deprecation, I guess, is really the only one you would see. Will the following code compile without error? Why or why not? So will the following code compile without error? Why or why not? Interface meal, breakfast, main dish, cereal, meal, lunch, main dish, pizza, dinner, main dish, salad, evaluate diet. So this will not compile, and the reason is that the annotations need to be marked as repeatable in order to be used this way. So public interface meal. So this specifies actually an annotation, right? When you use this at interface annotation, it means that this is itself an annotation that we're specifying. And then we're now using that annotation on evaluate diet, but we're using it repeated times. So you need to do, if you want to use it, is to create another containing annotation container, another custom annotation. And then you have to add the meta annotation to this interface, this meal annotation, that it's repeatable, and then specify in that repeatable annotation, in the annotation, that at repeatable annotation, specify the containing class that you create. So you might have the meals interface, or rather the meals annotation, and then you just have to specify at repeatable with meals.class as a parameter to that repeatable annotation, meta annotation, and then it would work. So that's number 3. Let's actually look at the answers for 2 and 3 before we move on. Throws a warning, right? We can deprecate the implementation of open. What can you do to get rid of that warning? It's deprecated. You can deprecate the implementation of open. Documentation is inherited from the interface. Alternatively, you can suppress the warning. Yeah, I was saying we can suppress it, but also, you can deprecate the implementation of warning too. Okay, interesting. Inherited from the interface. Documentation inherited from the interface. Oh, I didn't think to do that. Oh, you can actually just deprecate that too. Okay, interesting. Did not even consider that. It's a good thing we looked at the answer. Will the following code compile that error? Why or why not? Code fails to compile. Before JDK 8, repeatable annotations are not supported. As of JDK 8, the code fails to compile because the meal annotation type was not defined to be repeatable. Can be fixed by adding the repeatable meta annotation defining container annotation type, right? Which was, I said that, but I said that in a very long-winded way and not in the most obvious way. not the clearest way. And java.lang.annotation.repeatable. Yeah, there you go. Okay. And I was meal container. I was just going to say meals, but meal container works too. And you have to have this particular. You need to have that particular member, I guess, for the annotation, where it's an array of meals, and its value is the name. And I guess they all have these parentheses too. So, okay. Okay, wait. So let's look at define an annotation type for an enhancement request with elements. Define an annotation type for an enhancement request with elements ID, synopsis, engineer, and date. Specify the default value as unassigned for engineer and unknown for date. So you can do, it would be like public, add interface, enhancement, opening curly braces. First line we're going to put int ID, string synopsis, string engineer, default unassigned as a string, and then date. I guess I'll also make that a string and say string date default unknown, and then all of those, each of those lines have opening and closing parentheses following each of the names. So ID would have an opening closing parentheses, synopsis same thing, engineer same thing, date same thing, and then you have a closing curly braces, and that should give you your annotation. So it should look something like that. I realize communicating that orally is pretty awkward, but I don't want to type it. Just rather not. Request for enhancement annotation type. So I just said enhance. Oh, request for enhancement. Okay. I should say request for enhancement or enhancement request. That's what I should have said instead of enhancement. But okay. ID, string, engineer. Oh, okay. They used brackets too. I wasn't going to use brackets. But all right, fair enough. Okay, great. So that's good. So that gives us annotations. So we read through the whole thing. Got it. And we've got other things to read, the Java tutorials. How are we doing on time here? So yeah, we spent like an hour or so going over all that annotations. Suppressed warnings. So I kind of get it with suppressed warnings. I get it. Oh, I see. The target could be a number of things. So I was wrong before when I said type. Looks like it includes all of them. I was incorrect. So it looks like it's actually a set of things that you could pick from. All right, we don't really have to read all this. I think we can kind of move on. I suppose. I get a better sense now what target and retention is supposed to mean. And documented means it's got something to do with the Javadocs. I don't really know what this does as safe vargs. Programmer assertion that the body of the annotated method or constructor does not perform potentially unsafe operations on its vargs parameter. I don't know what that means. Applying this annotation to a method or constructor suppresses unchecked warnings about a non-reifiable variable arity varg type and suppresses unchecked warnings about parameterized array creation at call sites. Again, don't really know what those things are. In addition to the usage of restrictions imposed by its target meta annotation, compilers are required to implement additional usage restrictions on this annotation type. It is a compiler time error if a method or constructor declaration is annotated with a safe vargs annotation and either the declaration is a fixed arity method or constructor, the declaration is a variable arity method that is neither static nor final. Oh, okay. So you can't use safe vargs annotations in certain cases. Compilers are encouraged to issue warnings when this annotation type is applied to a method or constructor declaration where the variable arity has a reifiable element type. I don't know what that means, reifiable element type, which includes primitive types, object, and string. The unchecked warnings this annotation type suppresses already do not occur for a reifiable element type. Gotcha. The body of the method or constructor declaration performs potentially unsafe operations such as an assignment to an element of the variable arity parameters array that generates an unchecked warning. Some unsafe operations do not trigger an unchecked warning. For example, the aliasing in here leads to a class cast exception at runtime. Future versions of the platform may mandate compiler errors for such unsafe operations. Okay, don't really get it. Still don't really get it. Non-reifiable variable arity type and suppresses unchecked warnings about parameterized array creation at call sites. A little confusing. Yeah, I don't really know. And I just don't know what they're saying. I don't know what those things are. I have to go look those things up too. Not actually safe. Static void list string, string lists, object array equals string lists, list integer, temp list, arrays, not as list, array 0 equals temp list. So semantically invalid but compiles without warnings. Interesting. S equals string list dot get. Oh no, class cast exception at runtime. Okay. So what's going on here? So it's not actually safe. We create an object array of the string lists, and then we create a list which takes your arrays.asList of 42. So we create an array with really it would be we take oh, that's so confusing. So we create a list, I think, from 42 of integers. So it's a list of just one integer. And then we say array of 0 equals temp list, which is that a list of one integer, which is not right semantically invalid, but works for some reason. That's strange. And this is also, because it's an object array, we set this to the object is the list integer. So now that object is a list integer rather than, and it's interesting because we originally set this array to string lists. So that's super confusing, but basically you have an object array where the objects are all strings, and now the first element we're changing it from a string to a list integer object, which the meaning is nonsense, but technically you can do that. You can take it is an object, that list, even though it's a list collection, that itself is an object. And then you say string s is going to be string lists of 0, so that object dot get 0 class cast exception. I think at runtime the reason for that is because it's an object, not a string list. Excuse me. And not only that, but that particular object is not a well, actually, you would get an integer. Really, that get 0 might actually work. You would get the first element of that list, but then it's not a string that you're returning; it's an integer. So you should get some kind of an exception. But class cast exception, I guess, means that you can't cast an integer to a string. So that's a super interesting. Super interesting kind of situation to be in, but what they're saying here is the body of the method or constructor declaration performs potentially unsafe operations, such as an assignment to an element of the variable arity parameters array that generates an unchecked warning. Some unsafe operations do not trigger an unchecked warning. For example, the aliasing leads to a class cast exception at runtime. So assignment to an element of the variable arity parameters array. In that case, this should actually give us an error. So it's saying if you try to assign something to this array, okay, right, okay. So there's might be more to that. I'm not going to go over it. I have some questions, but I don't want to go too far into that. It's not that critical, I think, to learn more about safe varargs. I mean, how often are you actually even using varargs? I guess if I see variadic code somewhere, I'll probably go back and go learn about this annotation. But doesn't seem so important to me. All right, Javadocs. Javadoc is a tool that parses the declarations and documentation comments in a set of source files and produces a set of HTML pages describing the classes, interfaces, constructors, methods, and fields. You can use a Javadoc Doclet to customize Javadoc output. A Doclet program is a program written with the Doclet API that specifies the content and format of the output to be generated by the tool. You can write a Doclet to generate any kind of text file output, such as HTML, SGML, XML, RTF, and MIF. Oracle provides a standard Doclet for generating HTML format API documentation. Doclets can also be used to perform special tasks not related to producing API documentation. Oh, so you can parse your API, your source code, and generate documentation or text files, and not necessarily documentation, but for the most part it seems to be documentation. A taglet is a program that allows you to create and use custom tags that are more flexible than custom tags created with the dash tag option. A custom tag is used by a doclet to format and display text from a Javadoc tag. A taglet must implement the taglet interface. So there's an API specified for the Javadoc. Following our APIs related to Javadocs, Doclet API, Taglet API, Doctree API, Javadoc Access API tools. There's a reference page. Following tool pages list all Javadoc tags and command line options for running the Javadoc tool. Examples for the Solaris and Microsoft Windows operating systems. Tutorials and programmers guides. And tutorials and guides for Javadoc APIs. Doclet Overview. Introduction to standard doclets includes simple examples that illustrate the Doclet API. Running the standard doclet. This doclet produces the default HTML format API documentation. Javadoc uses the standard doclet. No other doclet is specified with the Javadoc doclet option. Transitioning to the 5.0 Doclet API. This document provides tips to extend legacy doclets to support 5.0 new language features. Taglet Overview. This introduction to taglets includes simple examples that illustrate the Taglet API. API enhancements. The following lists features and enhancements for Javadoc and given releases. Okay. That's a lot. We're not going to really get into all that, I think. We're just because I kind of have other things to get to. But more information, visit the following. Deprecation. Deprecate APIs are and how to deprecate APIs in the documentation generated by the Javadoc tool. Javadoc FAQ. View important tips and workarounds for bugs. Forum into discussions with fellow developers. This forum is monitored only occasionally by the Javadoc team. Okay. There's a forum and FAQ, deprecation, 1993, 2021. Whoa. Whoa. A lot going on. All right. How much time? Yeah, an hour and a half. Okay. Wow, it doesn't feel like that. It feels like we just spent like an eternity reading all this stuff. It feels like we spent so much more than an hour and a half. I don't know why. I mean, we're just reading different things, I guess. Annotations and yeah. So Javadoc is its own basically program and API for generating files based off of the. What does it say? It says it parses the declarations and documentation comments in source files and produces produces text files describing the class interfaces, constructors, methods, and fields. Okay, interesting. And then there's APIs that perform this, and there are programs that have been built, tools that have been built to do this. I guess you probably want to serve your Javadocs from a server somewhere, something like that. Because I was really confused by that. When I was younger, I heard about Javadoc and I never used it, and I was so confused. It was like, why? What is this? Why is it good? Why would you use it? All those kinds of questions. Well, as it turns out, like with websites, the idea is to just access information on another machine. So you can actually save the Javadoc output locally on your machine and just refer to it whenever you want. But probably the best thing to do is put it up onto a server, onto a machine, so anybody who's interested can go read the documentation for your code. And this basically just automates documentation. That's kind of like the bottom line. It just automates documentation for your code, which is good. It's generally a good thing. So yeah, okay, great. What's next? Annotation Documented. Yeah, and this is useful for your Javadocs, right? Indicates that annotations with a type are to be documented by Javadoc and similar tools by default. This type should be used to annotate the declarations of types whose annotations affect the use of annotated elements by their clients. If a type declaration is annotated with documented, its annotations become part of the public API of the annotated elements. What did I just read? Sorry, I'm like my mind, I'm not really focusing. Indicates that annotations with a type are to be documented by Javadoc and similar tools by default. Okay, this type should be used to annotate the declarations of types whose annotations. This type should be used to annotate the declarations of types, I'm so confused. By this type, do they mean documented? Like this annotation should be used? I'm not sure. This type, maybe the type that's being documented. This type should be used to annotate. By type, I think they mean like a class, maybe. I'm not sure what they mean by type. The word type is kind of used a lot in these different documents that we're reading, and it gets so confusing to me. I don't understand what they mean by type. Seems to be kind of ambiguous. It seems to mean like a lot of different things. Indicates that annotations with a type are to be documented. What does it mean with a type? What does that mean to have a type with a type? Or to be documented by Javadoc and similar tools by default. I don't really understand what this says. I mean, I understand that this is a message. This means that the things that have this annotation should be documented by the Javadoc. I get that, but I don't know what they mean by type and indicates that annotations with a type. That I'm kind of stuck on. This type should be used to annotate the declarations of types whose annotations affect the use of annotated elements by their clients. Whose annotations affect the use of annotated elements by their clients. This type should be used to annotate the declaration of types whose annotations affect the use of annotated elements by their clients. I'm kind of lost. There's too many things there I don't really understand. I'm trying to understand from the context, but I'm not getting it. So if a type declaration is annotated with documented, okay, that makes sense. So if a type declaration is annotated with document, so I guess type is like class, interface, method, any of those things maybe is a type. If a type declaration is annotated with documented, its annotations become part of the public API of the annotated elements. Public API of the annotated elements. Annotations become part of the public API of the annotated elements. Yeah, I kind of get that. So the annotations of that type also become part of the API. I think that's what's being stated here. This type should be used to annotate the declarations of types whose annotations affect the use of annotated elements by their clients. Indicates that annotations of the type are to be documented by. Oh, this is a meta annotation. Oh, that's why I'm so confused. Okay, I get it now. That's why I'm struggling so much. Okay, documented as a meta annotation. It's actually an annotation for another annotation. So indicates that annotations with a type are to be documented by Javadoc and similar tools by default. So you're going to document the annotations as well with Javadoc. That's what that means. This type should be used to annotate the declarations of types whose annotations affect the use of annotated elements by their clients. Oh boy, that's a doozy. So this type meaning, I guess documented is the type they're describing. I'm actually not sure what they mean by this type. Which type? Should be used. The annotations with the type are to be documented by Javadoc and similar tools by default. This type, I guess the type that you're documenting, you're adding documented to, should be used to annotate the declarations of types whose annotations affect the use. Forgive me, this is like pulling the teeth. Annotate the declarations of types whose annotations. So I think it really means to say documented. Instead of saying this type, we just say documented. Documented should be used to annotate the declarations of types whose annotations, so these different things that we're going to annotate with documented, their annotations affect the use of annotated elements by their clients. So the things that are annotated elements, so there's annotated portions of these, I guess classes we'll call it, or types, and those annotations affect the use of annotated elements by their clients. Yeah, so that's a really confusing way of saying when you're using that API, that class or method or whatever, I guess when you're using that type, the annotations on that type are meaningful and it will affect the usage. And so those things that have such annotations should be annotated with a documented annotation in order to make sure that those annotations are included in the Javadoc. I think that's what they're explaining here. That is like a very challenging line of English right there. I really had a hard time understanding, and I'm still not sure if I really comprehended that. But talk about English comprehension right there. Like that is, whew. Maybe an example would be a good idea. This really should just have an example. Like some of these things are a little bit too abstract and really should have an example. In my opinion. Yeah, this also, it's funny about this is like I wanted to read this to get a better idea of what documented means, and I'm just sitting here thinking I have no idea what this line of English means. Oh man, that's funny. It's just a lot of different concepts here, I guess. I don't know. It's my excuse. Yeah, comprehension really matters a lot. Comprehension matters a lot. Okay. Whoa. Annotation type inherited. Okay. So also in a meta. Yeah, we're looking at meta annotation, so that's kind of why it's a little bit confusing to like understand what we're reading, to comprehend it. Indicates that an annotation type is automatically inherited if an inherited meta annotation is present on an annotation type declaration and the user queries the annotation type on a class declaration. The class declaration has no querying, probably through the reflection API. Class declaration has no annotation for this type, then the class's superclass will automatically be queried for the annotation type. This process will be repeated until an annotation type of this type is found or the top of the class hierarchy is reached. Object. If no superclass has an annotation for this type, then the query will indicate that the class in question has no such annotation. Note that this meta annotation type has no effect if the annotated type is used to annotate anything other than a class. Note also that this meta annotation only causes annotations to be inherited from superclass. Annotations on implemented interfaces have no effect. Okay, that one's a little bit easier to understand because you can just say like the query, basically you're saying you have a subclass, you're querying it for an annotation using the reflection library, and then you're saying that, well, the inherited annotations basically mean that that query will also check the other parent classes of this class to see if those have it before returning that it's not there. That's a little bit simpler to understand. The documented one, I think, just means that you want your annotations to, it's a meta annotation to tell the Javadoc tools to also include the annotations of the other annotations, or the annotations that the meta annotation is annotating, that the other annotations will be included in the Javadoc output. Yeah, I think it's that simple for documented. I think we could explain it that way. Whatever they wrote, this just really was so confusing to me. Repeating annotations, we went over that before. Pretty interesting. You have a container, and you also have the meta annotation of repeatable. Pretty neat. We have it repeated a few times. Predefined annotation types, we read this already, right? It's only 5. Deprecated overrides, press warnings, safe varargs, which I kind of went over. It was a little confusing. Didn't really understand it. And then functional interface, I don't think I really understood either. I think we'll read that one shortly. And those are not meta annotations. Those are just regular annotations. They're not custom either. Custom annotations. And then, or user-defined annotations rather. Type annotations, a pluggable system. We went over that. So you can use annotations in the checker framework, for example, to perform compile time checks for certain things. which is pretty interesting. That was like a almost 40 chapter manual involved with the checker framework, and there were all kinds of other hyperlinks to other things. So that's quite the thing. But let's presume we don't really need that at the moment. But you could always add that to make your code a little bit more hostile to bugs. So Java Lang, although again that takes a certain amount of investment in terms of time to get familiar with that. So annotation type functional interface, Java.lang, documented retention value run type, target value type. Yeah, I don't know what this is. We should look at that actually. Element type. Class interface, including annotation type or enum declaration. Oh, okay. That's what I thought. Okay, so it's a class interface or an enum declaration, right? Which is basically like a, enclosing curly braces, I guess. Something that encloses it. Yeah, well, okay. Class interface, enum. Got it. Those are types. Understood. So functional interface and informative annotation type used to indicate that an interface type declaration intended to be a functional interface as defined by the Java language specification. What does that mean? I don't know. Conceptually, I'll explain it here. Functional interface is exactly one abstract method. Since default methods have an implementation, they're not abstract. What does it mean to be default? If an interface declares an abstract method overriding one of the public methods of java.lang.object, that also does not count toward the interface's abstract method count, since any implementation of the interface will have an implementation from java.lang.object or elsewhere. Got it. Note that instances of functional interfaces can be created with Lambda expressions, method references, or constructor references. If a type is annotated with this annotation type, compilers are required to generate an error message unless the type is an interface type and not an annotation type, enum, or class. I guess an annotation itself can be a type. The annotated type, and again, this is not a meta annotation, so that's why it's an error, right? The annotated type satisfies the requirements of a functional interface. So if it's not one of these things and it doesn't have those requirements, then we get an error. However, the compiler will treat any interface meeting the definition of a functional interface as a functional interface, regardless of whether or not a functional interface annotation is present on the interface declaration. Fair enough. It's really just informational for the person reading the code. So if anyone reading your code, including yourself, that's just to indicate to them what it's supposed to be. Is default returns true if this method is a default method, returns false. Otherwise, the default method is a public, non-abstract instance method. Thus, that is a non-static method with a. Oops, let me just scratch myself. Non-static method with a body declared in an interface type. Public, non-abstract instance method that is a non-static method with a body declared in an interface type. Okay. True if and only if this method is a default method as defined by the Java language specification. Got it. So, well, that's okay. We don't have to go spend more time on that. Retention policy. So this is about the right. If it's in we were asking before, if it's in the source code, the compiler, and the runtime. So being in the source code means that the annotation is tossed out once compilation starts. If it's compile time, then the compiler is aware of the annotations, but it gets tossed out when the program is running. The annotations won't show up in, for instance, the reflection library at runtime, and then for use with the reflections library, and then finally the runtime retention means that it's available at all three stages. Right? It's available in source code. It'll be in the source code. It'll make it to the compiler. It'll be in the source code. It'll make it to the compiler, and it'll make it to the runtime for examination using the reflection library. I don't know if the reflection library you can actually modify things. I know you can examine things, but I don't know if you can actually change it at runtime. So you can actually change the set of methods for a class at runtime or things of that nature. I doubt it. I get this impression that probably you couldn't do that, but maybe you could. I don't know. It seems like you'd probably break your program very easily, very quickly if you were allowed to do those things. So that's maybe why you probably can't, but it would be interesting to do that. I do know it's what you could do, which is kind of neat, is you can actually load a dynamically loaded linked library, compile source code So write source code, compile that into run a compilation process on that source code to generate another dynamically linked library, and then link to that dynamically linked library, and then unlink from the first library. So you link to a library to make use of it or what have you. Generate another library effectively, programmatically, link to that library, and then unlink the first library. And in that way, you can actually have a program that is constantly recompiling itself. Really, like the source code that you're compiling could actually be the program that constitutes that running program. So you could, if you wanted to, in theory, you could have sort of perpetually re-updating, self-updating program, which is kind of neat. Not that that's really all that significant, actually, because ultimately you do update. The person usually a person updates software and writes code, but you could actually automate that too. And if you could automate the code writing process too, and you can automate the updating and the code writing, you can automate the whole thing. It could grow on its own, self-growing, self-developing programs. I don't know what you call those kinds of. What would you call that? Pseudo-organic programs, right? Programs that generate themselves, or grow on their own, and without human intervention, I guess. That was a concept I tried to express many years ago, and I got laughed at by some people at the C++ conference because I couldn't really fully articulate the idea, and they just thought I was crazy. I was just making stuff up. But that's actually what I meant. It was like there must be a way to actually you could write a program that recompiles its own source code and also changes its own source code and then recompiles it. So at runtime it can actually but you would need to do that using dynamically linked libraries, because statically linked libraries are just, like, by definition, once it's in there, that's it. You have to actually shut down the program, start it again. But it's not like you couldn't run another instance and start another thread of another instance where it was statically compiled, and then once that's running, that new instance close the program that is running now, and then you have another program, and then maybe you just have shared resources, so you have like write to an output, serialize some output, have the other program, when it starts, it absorbs all that output, right, whatever state that you want, and so now that program's running another state, but it's running, and then you close this one, and you can do it that way too, where you actually share, it actually moves, shifts like control from one program to the next. That's not using a dynamically linked library. You can do that too. But yeah, anyway, I don't know. Those are fun ideas, but they're not, they're very sci-fi kind of. Basically the idea is that you'd have some kind of machine learning component in there where it's examining the requirements that it has to sort of figure out what it's supposed to be doing, and as it figures out new things that it should be doing, generates code and restarts itself, basically kind of molts out of its shell into it, once it needs to do the next thing. Basically molts from state to state as it's kind of figuring things out, gathering more information about what its goals are and how to achieve those goals and things like that. So yeah, you could have sort of like a pseudo-organic program agent that molts. You could do that. That could be fun. I don't know. I don't know what use case that might have. I don't know. Maybe you could use like a web scraper kind of thing, and like as it gathers more data. But like it has to have some kind of a goal that it's trying to achieve. And also, right, the idea is we're trying to have source code that's human readable, so we can know vaguely, we can understand like what it's trying to do and how it's trying to achieve it. So instead of just like machine learning parameters that you have, right, because that's sort of the deal with machine learning. It's basically like a function that the data points are it's basically trying to solve mathematically a function that follows data points. And approximates sort of the area, the sort of parameters in between those data points, or it basically gives you a rough guess of what that might be. Whereas And that's not really so easy to understand, because you can use those functions to make decisions, but like to understand the decision-making process, it's kind of like, well, this is just these are the parameters that it determined mathematically, like probabilistically. Like it's not a very coherent explanation of what's happening and or why. But if you could remap that to actually writing source code that's human readable, then it basically decides this is the algorithm that we should use to do XYZ thing. And it figures that somehow mathematically, I don't know, automatically, then I don't know, I guess you could have a better idea of what it's doing. I don't know. That's just an idea. I mean, because they have machine learning programs that kind of figure out problems automatically in decision making kind of matrices automatically, but based off of data. But you could also like employ I guess the algorithms that are used when these decisions are made. I don't know. I'm kind of getting off now because I don't actually fully understand how those things are done, really. So maybe we shouldn't get into that. But my thinking is that if you could actually document as you go, like as the machine learning program is learning stuff, it could kind of document what it's doing and why. And then you'd also have very strong legal case. Like in other words, if you're trying to follow laws with programs that are sort of autonomous, you have a much better chance in the courts, I think, with autonomous programs that could describe themselves than you do with programs that are that are just silent, right? That are totally ignorant about what it's even doing. Because when it makes a bad decision, then you can't really assess like why. You're just kind of like, oh, how are we going to explain that to the lawyers? Yeah, or the prosecution, really, right? Because presumably you hurt somebody doing that, or lost a lot of money doing that, or whatever. It's something very, very, but potentially immoral, even, right? Potentially even immoral. Anyways, that's the retention policy, right? It makes it to all three steps, right? If it's at runtime, so compiler, source code, compiler, and runtime. Okay, neat. All right, we didn't finish what we were doing though. Like we still have 8 more challenges to go, so maybe we should get on that. Okay, we're getting close though. Excuse me, we're getting close. All right. Java allows for covariant return types, which means you can vary your return type as long as you're returning a subclass of your specified return type. Okay, what does that mean? Method overriding allows a subclass to override the behavior of an existing superclass method and specify a return type that is some subclass of the original return type. It is best practice to use the @override annotation when overriding a superclass method. I don't recommend that, by the way. I don't recommend overriding a superclass method just at all in general. I think it violates the Liskov substitution principle. Implement the classes and methods detailed in the diagram below. So we have superclass, subclass, Jasmine, Lotus, Flower, and we have region, Andhra Pradesh, and West Bengal. You will be given a partially completed code in the editor where the main method takes the name of a state, West Bengal or Andhra Pradesh, and prints the national flower of that state using the classes and methods written by you. Do not use modifiers in your class declarations. Covariant return type, Java covariant return type. We'll read these things. The locked code reads a single string denoting the name of a subclass of state, West Bengal, Karnataka, or Andhra Pradesh, then tests the methods associated with that subclass. You are not responsible for reading any input from standard in. You are not responsible for reading any input from standard in. Okay, output format. Output is handled for you by the locked code, which creates the object corresponding to the input string's class name, and then prints the name returned by that class's national flowers. What's your name method? You are not responsible for printing anything to standard out. Andhra Pradesh, Lily. Andhra Pradesh objects, your national flower method returns an instance of the Lily class, and the Lily class's what's your name method returns Lily, which is printed by the hidden code checker. Okay. Complete the classes below. All right. Well, I don't know what the expectations are here, by the way, and we're going to go ahead and sit down again. because actually programming, typing is a little bit awkward for me standing like that. So this should be okay. So, okay, well, main IO exception reader, West Bengal, New West Bengal, Andhra Pradesh, flower region, your national flower, print, what's your name? So these are all classes. What do they want us to do though? We don't have the flower class here. Okay, well I guess that's the idea. So flower is region.yournationalflower. Region. Interesting. Okay. So a region is got to have your national flower. And that's going to return a flower object. And we return, depending on the region. So this is going to be this virtual dispatch, right? That's kind of what we're looking at here. So return a flower of the certain region, West Bengal, and actually we can make this abstract. Right? And then West Bengal extends region, extends region. Now, one question is, are these supposed to be interfaces or just inherited, or superclasses, right? They're just superclasses, okay. So, West Bengal, Andhra Pradesh, and then the flowers. Flower, jasmine extends flower, and lily extends flower, and what is it? It's Andhra Pradesh is lily, and West Bengal is jasmine. Okay, and then both of these just return what's your name. Lotus is lotus, and jasmine is jasmine. Oh, we don't have lily though. Interesting. Lotus, lily, I guess. Flower have many names and types. Interesting. So I made these abstract. I don't know if that matters. I mean, what's being called here shouldn't matter. Yeah. Actually, no, it does matter what region we have here, what we read, what the inputs are. So we do need to have each of these. So they're not abstract. So we have flower, your national flower, what's your name? I have many names and types. Okay. Got it. We might have a problem here because we don't have lotus anywhere. We just have lilies. I think we're okay, but we'll see how it goes. So this is not abstract. National flower, return new flower. Flower has what's your name. Return I have many names and types. Right. What's your name? I have many names and types with a period. There we go. Okay. Flower, we're going to add override. And the value for, so add override, we could say value equals the function name, I think. Something like that. Actually, I don't know if you need, add override has anything to add here. Let's see. Also, something's going on with my browser where you could see the font isn't really what it's supposed to be. Like the font looks kind of strange. I don't know. Sometimes when I see that, I feel like I got hacked or something because there's something up. Something's wrong with the JavaScript, I guess. If that makes sense. Yeah, I don't know what it is. It's a little weird, but I'm not gonna worry about it too much. Like I think like when I see that, it gives me the impression that like the web page is being modified so that way when I access the web page, I'm actually not going to the right web page. I'm actually seeing like modified search results, and it makes me think that yeah, my computer might have some program or something on it, which actually we can do. We can run a let me check for updates, and then we can run a scan and see what happens. It's more than possible that I end up clicking on something with respect to my. It's more than possible that I clicked on something in my emails, and that ended up taking me to like a fake web. Excuse me. More than possible that I ended up clicking on something in my emails, and that took me to a fake website, and that downloaded something to my computer. So let's run a scan. So yeah, okay. So anyway, override. Right. So value no. Yeah, it doesn't have, this annotation doesn't have like members that we specify, right? Yeah. So there's nothing to do there. Okay. So you could use these, but there's nothing in them, so you can remove those too. Okay. So extends flower string, what's your name, and then the name of the flower. Jasmine, or the class name. And then the other one is Lily. Same deal. Oops. The region, your national flower. Again, override. Excuse me. So we said West Bengal is Jasmine, and the other one must be Lily. And this is Lily, we said. And I wonder, yeah, okay. What happens if we do this now? Oh. Forgot that part. Okay. Sure. All right, let's go for it. See how we do. All right, only 2 test cases. Fair enough. I thought there could have been multiple test cases for the. Could have been multiple test cases for the. There could have been multiple test cases where the region or the flower wasn't specified, and so it was just a flower type rather than a lily or a jasmine, or the region could have been just the region itself, not the 2 different regions that were stated. Although actually I could have been wrong about that, because I don't know what the default was. I missed that actually. Maybe I'm wrong. The switch statement maybe just excluded those things, or didn't count those things, or did not include those things. Java 8 challenge, test your knowledge of Lambda expressions. There we go. There we go. We still have to read these covariant. Meaning of covariant return types in Java. We'll read that shortly. Okay, so we have Lambda expressions to learn about too. Yeah. We were looking at this earlier, but we'll read it again after we solve the problem. Write the following methods that return a Lambda expression performing a specific action. Perform operation is odd. Lambda expression must return true if a number is odd or false if it is even. Perform operation is prime. Lambda expression must return true if a number is prime or false if it is composite. Is palindrome. The Lambda expression must return true if a number is a palindrome or false if it is not. We're going to use a big integer library for the primality checks, by the way. Palindrome or not. If a number is a palindrome. Interesting. Okay. Input is handled for you by the locked stubcode in your editor. The locked stubcode in your editor will print t lines of output. First line contains the integer t, the number of test cases. The t subsequent lines each describe a test case in the form of two space-separated integers. First integer specifies the condition to check, 1, 2, or 3. The second integer denotes the number to be checked. I'm actually going to read the palindrome as a string and the prime value as a string as well. Odd or even, that one's a little bit easier. Yeah, so, okay. Sample about even, prime, palindrome, odd, composite. Okay. And we want but they want lambda expressions for each of these, right? Oh, okay, we don't actually have to parse. They're going to parse as an integer anyway, so we'll convert that integer to a string then for our purposes. So my question is, is there a way to convert an array to a collection? Because that's what I want to do. I want to reverse the elements in the character array. Well, we could just, I mean, there's a routine we can run that's pretty simple instead of reversing. But I tend to prefer to do that, to just check if the reverse string is the same as the initial string for palindromes. So let's see. How do you reverse a string in Java? You could, I mean, you could Stack Overflow. Stack Overflow. String builder, reverse to string. Oh, okay. Interesting. In place using a character array. This would be normally how I would do it. Basically swap the left and right characters from two different pointers. No threats. Okay, no kidding. But yeah, okay, string builder, reverse, got it. String builder, string buffer. That's probably better. I'll probably just do it that way. Okay. So the question is, These need to be Lambda expressions though. ob.checker. Op num. Form operation. Interface check. P check num. So do I just need to okay, so there is okay, there we go. Got it. Yeah, I mean you can have form operation new and then we could define check and that gives you an anonymous class to run a function. But is palindrome? Yeah, so you need the op is dot is odd, and I mean these could just be inner classes. Something like this. I don't know if this is what they wanted exactly, but int a, return a modulo 2 equals 0. So this checks is odd, so it should be true if it's odd, right? Yeah, so odd. You can actually do this too. I like this one more, and with 1. And then you have class, what's the next one? Is prime. Now what's interesting is ob.isPrime, it's not a new isPrime object, but actually retrieves this perform operation. So actually you're going to return something more like this, return new perform operation. Boolean check inside here. I don't know if you override in a I don't know if you override in a I don't know if you override in a don't know if you override in a what am I saying here? I don't know if you override in a when you implement an interface. I don't actually know if that matters. I guess you do. Why not? But yeah. So this isn't a class anymore. It's actually just a method. And we're going to say public. Oh, we don't know what this return type is though. Well, perform operation, right? Yeah. I think that's what we want. So we have is odd, we have is palindrome, and we have is prime, right? So prime and palindrome. Yeah, I mean, I don't know. You can call these lambda. These aren't really lambda expressions. I don't really know. This is how I would do it, but integer dot value of a. oh no, value, this would convert a string to an integer. So we actually want toString of A. I think that's the way to do it. Or we do string value of, something like that. I don't know, I think integer toString is what we want. And then we're going to say big integer bi equals new big integer of s, and then we're going to say return is probable bi.is probable prime with 1000 certainty, and that gives our primality check, and then our palindromic check. It's very similar. We could say string of A, and then we could say return, so well, we could just do string reversed as new string builder of s dot reverse dot toString, and then return s dot equals reversed. What does this compile? Let's start with that. No. Oh. So these return statements need to be have a semicolon at the end. Check in anonymous cannot implement check in Python perform operation. Oh, these need to be public. I tend to forget that too. There's 3 of these. Yeah, public. Compilation error. Bad operand types for binary operator. I think it's performing the right side first. I think that's why that happened. Cannot find symbol big integer. Oh no! Oh, we can't get our. Oh, it's so much easier if we import. Can we put the import here? I thought, where's big integer? I thought it was in the util. Java.math.big integer. Oh, it's up there. Well, I think we can probably do something like this. Hopefully we can still do this. Hey, there we go. All right, let's go for it. See how we do. Nice. Okay. Well, even though this solves the problem for us, we still have 6 more to go. Even though this solves the problem for us correctly, this doesn't really go over the Lambda expressions all that well. Yeah, we didn't really learn much about Lambda expressions. We just kind of implemented an interface with anonymous classes. So, yeah, interesting. Let's read Lambda expressions then. So how are we doing on time? I think we finished our scan to see if we have any viruses. So, I don't know. We don't have any viruses, so it's a little weird. I don't know what's going on with my web browser. I guess I just need to restart my web browser. Maybe it needs an update or something. One issue with anonymous classes is that if the implementation of your anonymous class is very simple, such an interface that contains only one method, then the syntax of anonymous classes may seem unwieldy and unclear. In these cases, you're usually trying to pass functionality as an argument to another method. That's kind of what we're doing here. So these are anonymous classes with just one function. It does seem a bit unwieldy, it's true. Although, I mean, you know, this is not too unwieldy. There's quite a bit going on there, but okay. Syntax of anonymous classes may seem unwieldy and unclear. In these cases, you're usually trying to pass functionality as an argument to another method, such as what action should be taken when someone clicks a button. Lambda expressions enable you to do this, to treat functionality as method, argument, or code as data. The previous section on anonymous classes shows you how to implement a base class without giving it a name, although this is often more concise than named class. For class is only one method, even an anonymous class seems a bit excessive and cumbersome. Lambda expressions let you express instances of single method classes more compactly. Covers the following topics. Ideal use case for lambda expressions. So suppose that you are creating a social networking application. You want to create a feature that enables an administrator to perform any kind of action, such as sending a message on members of the social networking application that satisfies certain criteria. Following table describes this use case in detail. Name, perform action on selected members, primary actor, administrator, preconditions, administrators logged into the system. Post-conditions, actions performed only on members that fit the specified criteria. Main scenario, success scenario, administrator specifies criteria of members on which to perform a certain action. Administrator specifies an action to perform those selected members. Administrator selects the submit button. System finds all members that match the specified criteria. The system performs a specified action on all matching members. Extensions 1A, the administrator has an option to preview those members who match the specified criteria before he or she specifies the action to be performed, or before selecting the submit button. Frequency of occurrence many times during the day. Suppose that members of this social networking application are represented by the following person class: public class person, enum sex, male, female, string name, local date, birthday, sex, gender, string email address, public int get age, public void print person. Suppose that the members of your social networking application are stored in a list person interface. Suppose that members of your social networking application are stored in a list person instance. Sure, this section begins with a naive approach to use this use case. It improves upon this approach with local and anonymous classes, and then finishes with an efficient and concise approach using lambda expressions. Section begins with a naive approach to this use case. It improves upon this approach with local and anonymous classes, and then finishes with an efficient and concise approach using lambda expressions. Define the code excerpts described in this section in the example roster test. Suppose the members are stored. There's a naive approach to this use case. Improves upon this approach. Local anonymous classes, and then finishes with an efficient and concise approach using lambda expressions. Find the code excerpts below. Describe this section in the example roster test. Create methods that search for members that match one characteristic. One simplistic approach is to create several methods. Each method searches for members that match one characteristic, such as gender or age. So we can create several methods. Simplistic approach is to create several methods. Each method searches for members that match one characteristic, such as gender or age. Several methods. Each method searches for members. One simplistic approach is to create several methods. Each method searches for members that match one characteristic. One simplistic approach is to create several methods. Each method searches for members that match one characteristic, such as gender or age. Following method prints members that are older than a specified age. Okay, fair enough. So print person older than age, or older than age. Yeah. So roster age. For each person, get their age. If it's greater than or equal to that age, print that person. Really should return a list, I think, but that's okay. List is an ordered collection. A collection is an object that groups multiple elements into a single unit. Collections are used to store, retrieve, manipulate, and communicate aggregate data. For more information about collections, see the collections trail. This approach can potentially make your application brittle, which is the likelihood of an application not working because of the introduction of updates, such as newer data types. Suppose that you upgrade your application and change the structure of the person class such that it contains different member variables, perhaps the class records, and class records and measures ages with a different data type or algorithm. You would have to rewrite a lot of your API to accommodate this change. In addition, this approach is unnecessarily restrictive. What if you wanted to print members younger than a certain age, for example? What if you wanted to print members younger than a certain age, for example? Okay. Have to rewrite a lot of your API to accommodate this change. In addition, this approach is unnecessarily restrictive. What if you wanted to print your members younger than a certain age, for example? Okay, so we create methods for each characteristic. Create more generalized search methods. Following method is more generic than print persons older than. It prints members within a specified range of ages. Okay. What if you want to print members of a specified sex or a combination of a specified gender and age range? What if you decide to change the person class and add other attributes such as relationship status or geographical location? Although this method is more generic than print persons older than, trying to create a separate method for each possible search query can still lead to brittle code. You can instead separate the code that specifies the criteria for which you want to search in a different class. Specify search criteria code in a local class. So we have a tester, right? Print persons, following method prints members and match criteria that match search criteria that you specify. Print persons, roster, check person tester. If tester.test, print person. This method checks each person instance contained in the list parameter roster whether it satisfies the search criteria specified in the check person parameter tester by invoking the method tester.test. If the method tester.test returns a true value, then the method print person is invoked on the person instance. To specify the search criteria, you implement the check person interface, check person boolean test person p. Following class implements the check person interface by specifying an implementation for the method test. This method filters members that are eligible for selective service in the United States. It returns a true value if its person parameter is male and between the ages of 18 and 25. So we have check person eligible for selective service, implements check person, test person B, gender, male, age, yeah. Okay, to use this class, you create a new instance of it and invoke the print persons method. Okay. Although this approach is less brittle, you don't have to rewrite methods if you change the structure of the person. You still have the additional code, a new interface, and a local class for each search you plan to perform in your application. Because check person eligible for selective service implements an interface, you can use an anonymous class instead of a local class and bypass the need to declare a new class for each search. Right? So you can put the class right in here and make it anonymous. Specify search criteria code in an anonymous class. So that's what they're doing here. One of the arguments of the following invocation of the method print persons is an anonymous class that filters members that are eligible for selective service in the United States, those who are male and between the ages of 18 and 25. Okay, here we go. So that's that. This approach reduces the amount of code required because you don't have to create a new class for each search that you want to perform. Well, you are creating you're creating that class at the time, right? At the time that you want to run that search. Syntax of anonymous classes is bulky considering that the check person interface contains only one method. In this case, you can use a Lambda expression instead of an anonymous class, as described in the next section. Specify search criteria code with a Lambda expression. The check person interface is a functional interface. A functional interface is any interface that contains only one abstract method. A functional interface may contain one or more default methods or static methods. May contain one or more default methods or static. So we said default methods are methods that are not static and it's defined the method. It's not abstract, not static and not abstract. And static methods are obviously static methods and also not abstract, I believe. So it contains only one abstract method though, and you can have these other methods though. Because a functional interface contains only one abstract method, we can omit the name of that method when you implement it. To do this, instead of using an anonymous class expression, you use a Lambda expression, which is highlighted in the following invocation. Okay, so I'm glad I finally took the time to read this too, because I think each time I wanted to learn about Lambda expressions, I kind of like quickly read through this or tried to, and I never really got it, never really understood it. Now I finally understand it. I think it may have also something to do with like I was saying before about information where if you don't know something when you're trying to read something, then the thing you're reading, it's going to make reference to other things that you don't necessarily know, and you have to go learn what those things are. And sometimes it's not obvious what those things are and how to learn those things or where to learn those things, all that. So it's a tricky thing with reading comprehension. It has a lot to do with what you already know. So obviously, like I understood immediately part 4, what they were talking about, but I don't think I would necessarily understand this immediately. Like this actually could be really, really strange to me and I think every time it was, I think I would often get stuck at part 4 because I just didn't know what they were talking about. But now I know what they're talking about is that interfaces, you can create an anonymous class using that interface name in this way, and I didn't know that, but you can do that. Yeah. Anyway, so now they're saying you can use a lambda expression, which is slightly different from this syntax, which is person P. Also, you're going to hear some. I charge my headset now. You're going to hear some. You're going to hear some buzzing because it'll be charging. Unfortunately, we're going to have some buzzing now. Right. So person P with an arrow, and okay, right. So person P is the argument, and then you have an arrow and we have a return value, right? A Boolean. And what's interesting is that this doesn't have the other kind of code around it, like the return statement, that's Boolean, all those different pieces. Print person's method it takes a check person object. So I think this will automatically be converted to a checked person object, and it'll automatically set up the right return value and things of that nature. So I guess you'll have to see the syntax for lambda expressions to how it's supposed to be defined, but that's interesting. So you can use a standard functional interface in place of the interface check person, which reduces even further the amount of code required. So I get, yeah, there's a functional interface that's not check person. So you don't even, so for your print person signature, it doesn't need to be check person. It could just be any, like just the functional interface, which exists. And any abstract functional interface works too. Approach 6, use standard functional interfaces with lambda expressions. That's now what they're just going to describe, I think, or show that. So reconsider checked person interface, very simple interface to functional interface because it contains only one abstract method. This method takes one parameter and returns a Boolean value. The method is so simple that it might be worth it to define one in your application. Consequently, the JDK defines several standard functional interfaces, which you can find in the package java.util.function. So you can define your own interface, or you can take one from the function package. Okay. For example, you can use the predicate T interface in place of check person. This interface contains the method Boolean test TT. The interface predicate T is an example of a generic interface. For more information about generics, see the generics updated lesson. Generic types, such as generic interfaces, specify one or more type parameters. Within angle brackets, this interface contains only one parameter T. When you declare or instantiate a generic type with the actual type arguments, you have a parameterized type. For example, the parameterized type predicate person is the following: interface predicate person, Boolean test person T. This parameterized type contains a method that has the same return type and parameters as checkPerson.Boolean test person P. So this parameterized type contains a method that has the same return type and parameters as checkPerson.Boolean test person P. Consequently, you can use predicate T in place of check person as the following method demonstrates: print persons with predicate, roster, predicate person tester, tester T dot test P, print person, P dot print person. Okay. As a result, the following method invocation is the same as when you invoked print persons in approach 3. Specify search criteria code in a local class to obtain members who are eligible for selective service. And so now you can use p.gender person.sex.male, and instead of specifying that this is a instead of using a what do they call it, instead of specifying that it's a person P, you can just say P, and that'll be automatically determined, I suppose. Yeah, that's kind of interesting. This is not the only possible place in this method to use a lambda expression. The following approach suggests other ways to use lambda expressions. Okay. Reconsider the method print persons with predicate to see where else you could use lambda expressions. So the lambda expressions would make the basically the anonymous class that you're returning that implements that function. You can actually make the syntax more succinct by actually returning a lambda expression that is effectively that that anonymous class that implements only one function, right? Because it's a functional interface that you're implementing. Okay, very interesting. Very interesting. This is like, yeah, okay. So see where else you could use lambda expressions. This method. So now we have a roster, a tester, checks each person instance containing the list parameter roster whether it satisfies the criteria specified in the predicate parameter tester. If the person instance does satisfy the criteria specified by tester, the method print person is invoked on the person instance. Okay, so now you can have the print person, I guess, could also be a lambda expression too, or another function as well. Instead of invoking the method print person, you can specify a different action to perform in those person instances that satisfy the criteria specified by tester. You can specify this action with a lambda expression. Suppose you want a lambda expression similar to print person, that takes in one argument, an object of type person, and returns void. Remember, to use a lambda expression, you need to implement a functional interface. In this case, you need a functional interface that contains an abstract method that can take one argument of type person and returns void. The consumer T interface contains the method void except TT, which has these characteristics. The following method replaces the invocation P print person with an instance of consumer person that invokes the method accept. So there is this block tester block.accept P. As a result, the following method invocation is the same as when you invoked print persons in approach 3 to obtain members who are eligible for selective service. The lambda expression used to print members is highlighted. Okay, so you can even update you have a predicate. So these are just generic functional interfaces that you can kind of define yourself if you wanted to. Like you can define your own functional interface, but you could also define. You could also use one of the provided generic functional interfaces that have classes involved. Okay, I see. I understand now. Okay, I get it. So you can use lambda expressions, but like a little bit more arbitrarily the way that you do it. You might do it in C++, but you just need to specify a functional interface for that lambda expression. Okay. What if you want to do more with your members' profiles than printing them out? Suppose that you want to validate the members' profiles or retrieve their contact information. In this case, you need a functional interface that contains an abstract method that returns a value. The function tr interface contains the method r apply tt. The following method retrieves the data specified by the parameter mapper and then performs an action on it specified the parameter block. So now you're going to do yet one more thing, which is you have a mapper, and on your block you're gonna perform an operation, and you're also going to set the data to this. You're gonna apply a function to map these persons to strings, and then you're going to perform an operation on that string. So it says maybe you want to validate their profile, retrieve their contact information. So maybe you want want to do more. So we have a function that you're going to call now, and then you're going to the result of that mapper you're going to operate on. So now you have yet another lambda expression you can use, and this is an abstract, right? A function interface. So has some function performs on T and returns R, return value R. So converts a person to a string. Following method retrieves the email address from each member contained in roster who's eligible for selective service, and then prints it. So eligible for selective service, you get the email address, and then you print the email address. Okay, very interesting. Use generics more extensively. Reconsider the method process persons with function. The following is a generic version of it that accepts as a parameter a collection that contains elements of any data type. So now instead of persons, we can, in strings and all of that, we can do X and Y, where you have some iterable source, some predicate on that, right? So iterable collection of objects will be persons. You have a tester for those persons. You have a function that maps X to Y, which is, in our case, is a string, could be whatever object you want. You process elements, and then you can say consumer block, so you map, get the data after you map our mapper, which is, so all these could be Lambda expressions, and this could be persons and strings in our case, but it just becomes more general with respect to really any objects you might want to use, where this is sort of a derived object from the other object. This is a iterate over that object. You have a predicate to test for the objects you want. You have a mapper for to convert those objects from X to Y, and then you consume the Y to process that further. And now it's much more general, right? To print the email address of members who are eligible for selective service, invoke the process elements method as follows. Roster is our iterable. We have our code for getting the gender, checking the age, and then we're going to get email addresses for each of those values that we've tested for, each of those people that we've tested for, and then finally we're going to actually print those emails out once we get those emails. This method invocation performs the following actions: obtains a source of objects from the collection source. In this example, obtains a source of person objects from the collection roster. Notice that the collection roster, which is a collection of type list, is also an object of type iterable. Filters objects that match the predicate object tester. In this example, the predicate object is the Lambda expression that specifies which members would be eligible for selective service. Maps each filtered object to a value as specified by the function object mapper. In this example, the function object is a Lambda expression that returns the email address of a member. Performs an action on each mapped object as specified by the consumer object block. In this example, the consumer object is a Lambda expression that prints a string, which is the email address returned by the function object. You can replace each of these actions with an aggregate operation. Phenomenal. Hey, okay, I get it now. I was so confused by this explanation of Lambda expressions early when I read it the first few times, probably because I was skipping around, but each of these steps build on the previous step. So it makes sense, a lot more sense now when you read it through. So you can use generics more extensively, and then now we can use aggregate operations that accept Lambda expressions as parameters. So now the following example uses aggregate operations to print the email address of those members contained in the collection roster who are eligible for selective service. So you can create a stream from the roster, then filter on that roster, then map each of the people that are left in the roster to their email addresses, and then for each email address you can perform so each of these Lambda expressions now, it's almost the same thing as what we just saw, but these sort of dot operations, these aggregate operations will actually apply Lambda expressions sort of in each of these ways, and each of these Lambda expressions will have kind of this format. Basically, there'll be implementations of these generic interfaces. And so you can do stream, creates an iterable out of roster. You can filter it. Now it's interesting that you can't just filter the roster immediately, but yes, I don't know what exactly the stream does, but it seems to turn the roster into an iterable that you can operate on, perform aggregate operations on, it seems, and then you can filter with a Lambda expression, map with another Lambda expression, and then run a for each routine on what's left over. And that's very clean, very concise way of performing these operations. Following table maps each of the operations the method process elements performs with the corresponding aggregate operation, process elements action, aggregate operation, obtain a source of objects, stream, filter objects that match a predicate object, filter predicate, map objects to another value as specified by a function object, R, stream R, map function, super extends mapper, and then perform an action that is specified by a consumer object, void for each consumer, super T action. So I don't know what this question mark means. That's it's new to me, but yeah. So we're just using some generics. We have generic stream objects returned, and then we have to get stream object. We can filter on a stream object, we can use a predicate map with a mapper, and question mark extends R. That's interesting. So any sub yeah, I don't know what this extends and super, like what this notation is. Super T, question mark super T means this is a, I think that means that this is any, I think the question mark is the class, and then super T means any subclass of T, this could be. So this could be any subclass of T, and then this is any, extends is the other direction. This is any, well, no, excuse me, any T or any ancestor of T, and then this is R or any subclass of T, I think. Any progeny of R, rather. It's not the progeny, it's the descendant, any descendant of R. So these are, I think this is any ancestor, T and any ancestor of T, and R and any descendant of R. And then this is T and any ancestor of T can be consumed. I don't know what this, again, I don't know what this syntax means, but at some point we'll learn that, I guess. Operations filter map, and for each are aggregate operations process elements from a stream, not directly from a collection, which is the reason why the first method invoked is, in this example, stream. A stream is a sequence of elements, unlike a collection is not a data structure that stores elements. Instead, a stream carries values from a source such as collection through a pipeline. Pipeline is a sequence of stream operations, which is, in this example, is filter map for each. In addition, aggregate operations typically accept Lambda Expressions as parameters, enabling you to customize how they behave. For more thorough discussion of aggregate operations, see the aggregate operations list. We should probably look into that too. I wonder, oh boy, I wonder about super, yes, question mark super T. Let's do that. Question mark super Java documentation question mark super T. Like, what does that mean? I'm trying to find, using the keyword super, like, I have questions about the Java excuse me, maybe we'll just look at stream aggregate operations so we can find out. Excuse me. So this is really interesting. I like this, using Java aggregate operations. Very neat, very interesting. What is this? Generic. Let's do generics. Let's do Javadoc generics. Maybe that's what we need. Generics tutorial by Gilad Raka. Any non-trivial software project bugs are simply a fact of life. Careful programming. Okay. I think I've already read why I use them. Generic types. Somewhere here. Oh. There is something. The Java documentation has something unusual which I haven't seen. I haven't seen, but I don't know. I'm looking for extends number. Oh, here we go. Okay. What is this? bounded type parameters. There may be times when you want to restrict the types that can be used as type arguments in a parameterized type. For example, a method that operates on numbers might only want to accept instances of number or its subclasses. This is what bounded type parameters are for. To declare a bounded type parameter, that lists the type parameter's name, followed by the extends keyword, followed by its upper bound, which in this example is number. Note that in this context, extends is used in a general sense to mean either extends as in classes or implements as in interfaces. Okay, so extends number, gotcha. By modifying our generic method to include this bounded type parameter, compilation will now fail since our invocation of inspect still includes a string. Okay. In addition to limiting the types you can use to instantiate a generic type, bounded type parameters allow you to invoke methods defined in the bounds. So this is bounded type parameters. Okay. So t extends integer means what? The isEven invokes the int value method defined in the integer class through n. Oh, I see. Since this extends integer, anything that doesn't extend integer won't work. Okay, multiple bounds. Preceding example illustrates the use of a type parameter with a single bound, but a type parameter can have multiple bounds. A type variable with multiple bounds is a subtype of all the types listed in the bound. If one of the bounds is a class, it must be specified first. For example, b1, b2, b3 extends each of those. Okay, that's interesting. Methods and bounded type parameters. So just looking for the thing I was extends comparable. Bounded type parameters are key to the implementation of generic algorithms. Consider the following method that counts the number of elements in an array T that are greater than the specified element. The implementation of the method is straightforward, but it does not compile because the greater than operator applies only to primitive types such as these. You cannot use the greater than operator to compare objects. To fix the problem, use the type parameter bounded by the comparable interface. The resulting code will be D extends comparable greater than compared to. Neat. Generics, inheritance, and subtypes. As you already know, it is possible to assign an object of one type to an object of another type, provided that the types are compatible. For example, you can assign integer to an object since object is one of the integer supertypes. Object-oriented terminology, this is called an is-a relationship since the integer is a kind of object the assign is allowed. Also a kind of number, so the following code is valid as well. It's a method number n, new. Okay, same as all true the generics. For a generic type invocation by passing number as its type argument, any subsequent invocation of add will be allowed if the argument is compatible with number. So number, integer double, because of the following method, box number n. What type of argument does it accept? By looking at its signature, accepts a single argument whose type is box number. But what does that mean? Are you allowed to pass in box integer or box double, as you might expect? The answer is no, because box integer and box double are not subtypes of box number. Common misunderstanding when it comes to programming with generics, but is an important concept to learn. Okay, yeah, it's a subtle thing. Concrete types A and B has no relationship to my class B, regardless of whether or not A and B are related. The common parent of my class A and my class B is object. Information on how to create a subtype-like relationship between generic classes when the type parameters are related. See wildcards and subtyping. Generic classes and subtyping. Subtype a generic class or interface by extending or implementing it. The relationship between the type parameters of one class or interface and the type parameters of another are determined by the extends and implements clauses. Using the collections classes as an example, array list E implements list E, and list E extends class collection E. So array list string is a subtype of list string, which is a subtype of collection string. So as long as you do not vary the type argument, the subtyping relationship is preserved between the types. Now imagine we want to define our own list interface, payload list that associates an optional value of generic type P with each element. Its declaration might look like payload EP extends list EP, set payload int EP value. Okay. Following parameterization of payload list are subtypes of list string. Okay. Wow. Type inference. To look at each method. Java compiler's ability to look at each method invocation and corresponding declaration to determine the type, argument, or arguments that make the invocation applicable. The inference algorithm determines the types of the arguments and, if available, the type that the result is being assigned or returned. Finally, the inference algorithm tries to find the most specific type that works with all of the arguments. To illustrate this last point, in the following example, inference determines that the second argument being passed to the pick method is of type serializable. Static, pick, serializable, pick, new or list string. How are we doing on time? Yeah, 3 hours now. Okay, just hit 3 hours. Illustrate this last point in the following example. Inference determines that the second argument being passed to the pick method is of type serializable. Static t, pick, tt, return at. Serializable s equals pick of string and a new arrayless string. So, So both of these are serializable. Okay. Oh, I see. Type inference and generic methods introduce you to type inference, which enables you to invoke a generic method as you would an ordinary method without specifying a type between angle brackets. Consider the following example box demo, which requires the box class. Box demo, public static, void, add box, UU, list box U, boxes, box U box equals new box, set U, add box to boxes, output boxes. I'm not going to read that code, we'll just leave it for now. List of integer boxes. Box demo, add box. Following is output from this example. Generic method add box defines one type parameter u. Generally, Java compiler can infer the type parameters of a generic method call. Consequently, in most cases, you do not have to specify them. For example, to invoke the generic method add box, you can specify the type parameter with the type witness as follows: box.demo integer add box integer.value of list of integer boxes. I guess you have to read this. Add box to boxes. Static void output boxes takes a list of box U, boxes of box U, boxes, counter 0. For each box of U in the boxes, we're going to take box contents, box.get, print, box number, counter contains, increment the counter, and the box contents is a toString. Okay, and then in main we have a list of integer boxes, a new array list. Becomes inferred, but box integers, and we say box integer add box, box demo dot integer add box, and we say integer dot value of 10. List of integer boxes, so the list that we're going to add to, add box. And these other two we don't need to add integer. And then finally output boxes. Don't even need to specify either. Most cases you do not have to specify them. Okay. So you can use a type witness if you want. Omit the type witness, it infers the type parameter. Gotcha. Type inference instantiation of generic classes. Okay, we got more to read here. I think we'll take a break for the time being. I'm just looking for target typing and Lambda expressions. Oh, that's a lot to read here. A lot to look at here. Oops. Yeah. Wildcards and subtyping. I'm looking for generic classes or interfaces. Oh, there we go. That's what we're looking for. Yeah. Super and extends, right. Okay. Okay, this is what we want to read. So as described in generics, inheritance, and subtypes, generic classes or interfaces are not related merely because there is a relationship between their types. However, you can use wildcards to create a relationship between generic classes or interfaces. Given the following two non-generic classes, class A, class B extends A, it would be reasonable to write the following code, new B, A equals B. This example shows that inheritance of regular classes follows this rule of subtyping. Class B is a subtype of class A. If B extends A, this rule does not apply to generic types. So class B is a subtype of class A if B extends A. The example shows that inheritance of regular classes follows this rule of subtyping. Class B is a subtype of class A if B extends A. Right, this rule does not apply to generic types. Right, so list B, list A, compile time error. Given that integer is a subtype of number, what is the relationship between list integer and list number? They're not related to each other, right? Although integer is a subtype of number, list integer is not a subtype of list number, and in fact these two types are not related. Common parent of list number and list integer is list question mark. In order to create relationships between these classes so that the code can access numbers methods through list integers elements, use an upper bounded wildcard. Question mark extends integer int list new array list. Question mark extends number num list equals int list. Okay, list question mark extends integer is a subtype of list question mark extends number. So something that extends integer is a subtype of something that extends number. Because integer is a subtype of number, the num list is a list of number objects. A relationship now exists between int list, a list of integer objects, and num list. The following diagram shows the relationships between several list classes declared with both upper and lower bounded wildcards. I see. So there's upper bounds and lower bounds. So the lower bound is that you extend numbers, and the upper bound is that you are a superclass of these numbers. Guidelines for wildcard use section has more information about their applications. Upper and lower bounded wildcards. Okay, so that's what these things are. These are wildcards. All right, I think someone may have mentioned that to me at some point, but it took me a while to find that. So it looks like I really just need to read the Java documentation. Like just read more. This seems to be my problem. It's a lot of reading. It's a lot of reading. Like, it's one thing to understand like the more abstract things like data structures and algorithms. It's quite another thing to understand the language documentation. I guess the language, yeah, I guess just the language documentation, language proficiency. I really think it is just a lot of reading. I used to think that it was a good idea to practice coding in that language. While it's not a bad idea, I think the best thing to do is actually just to read the language documentation and then solve problems with that particular language. Yeah, because you run into all this stuff and you're like, how do I, like, what are all these things that I'm looking at here? But yeah, there's quite a bit. I don't know, I complain about the Java documentation, but I think actually I shouldn't be complaining because it's pretty good. It explains the questions, it answers my questions. It's not, I don't know what my complaint is. I don't know, I guess there's different ways of documenting things. Yeah, but pretty interesting. So yeah, I really should go through this, read all of this. I think I just have a lot of reading to do, really, to get like the language proficiency in the right place. Same thing with like JavaScript and JavaScript, Ruby, and we're finishing Java fairly soon. But yeah, we kind of moved away. Well, because I wasn't sure what this meant, these wildcards. I was kind of wondering what this is. Guidelines for wildcard use section has more information about the ramification using upper and lower bound wildcards. So, okay, so list integer and list number, they're not related to each other, but they're all related to list wildcard. Now, a lower bound if you extend, if you're, so a list that has a wildcard that extends integer, right? This is anything that subclasses an integer. So the integer class would be would be related, would be a subclass of that. And anything that extends an integer, a subclass is an integer, would also be, because integer is a subclass of number, would also be a subclass of number. So anything that extends a number. This list integer is then a subclass of a list that extends integer. So I don't know which one's upper bounded or lower bounded. I think use an upper bounded wildcard. So this is upper bound wildcards, and the lower bound are supers. So list number is then also a subclass of the upper bounded wildcard. The upper bound is a number, and then obviously this wildcard is also just the list, any wildcard, right? Upper bounded on a number is also a subclass of the list up wildcard, and then the list number class is a subclass of the lower bounded list that's lower bounded by the number class. And now what's interesting is that the lower bounded number wildcard lower, so anything that has number as a parent class, right? That's what it means to be lower bounded, will then be a subclass of the lower bounded wildcard lower bounded by the integer class. So super integer is an upper class as a parent class of super number. Now why is that? What does it mean to be lower bounded and upper bounded? So lower bounded means this thing has a parent. No, excuse me. Extends means the parent is number. Super means that this is a parent of integer. Is that right? So yeah, so this is anything that's a subclass of number, and anything that's a subclass of integer is necessarily a subclass of anything that subclasses a number. That's really confusing too. Is that what it means? What does it mean to extend? I think we need to go. Yeah, we need to go over this guidelines. More confusing aspects when learning to program the generics determine when to use an upper bounded wildcard and when to use a lower bounded wildcard. Provide some guidelines to follow when designing your code. Yeah, I don't really know what it means, so I think I need to read this. Purpose of the discussion is helpful to think of variables as providing one of two functions. An in variable serves up data to the code. Imagine a copy method with two arguments, source, destination. The source argument provides the data to be copied, so it is the in parameter. Out variable holds data for use elsewhere. Copy example, copy source, destination. The destination argument accepts data, so it is the out parameter. Of course, some variables are used for both in and out purposes. This scenario is also addressed in the guidelines. You can use the in and out principle when deciding whether to use a wildcard and what type of wildcard is appropriate. The following list provides the guidelines to follow. Wildcard guidelines. In variable is defined with an upper bounded wildcard using the extends keyword. Out variable is defined with a lower bounded wildcard using the super keyword. In the case where the in variable can be accessed using methods defined in the object class, we use an unbounded wildcard. In the case where the code needs to access the variables as both an in and an out variable, do not use a wildcard. Okay. How they figured that out, I don't know. Do not apply to a method's return type. Using a wildcard as a return type should be avoided because it forces programmers using the code to deal with wildcards. Nice. Nice. A list is defined by list wildcard extends ... Can be informally thought of as read-only, but that is not a strict guarantee. Suppose you have the following two classes: natural number, private I, natural number, int I. Even number extends natural number. Consider the following code. Even number, list of even numbers is a new array list. Question mark extends natural number, ln equals le. Add new natural number, compile time error. Okay. because list even number is a subtype of list question mark extends natural number, you can assign LE to LN, but you cannot use LN to add a natural number to a list of even numbers. Yeah. The following operations on the list are possible. Oh, okay. Because natural number is a super type of the even number, it's not possible. So that's extremely confusing, and it's going to take me a while to think about this. I'll probably have to come back to this later, think about it, maybe think of some more examples. But so you have a list of even numbers which extends natural numbers. So then you can say anything that extends a natural number in this list, but you won't be able to add a natural number to this list even though you're extending a natural number, and they call this the upper bound, an upper bounded wildcard. And you can't add a natural number to a list of even numbers, but you can add a null, you can invoke clear, you can get the iterator and invoke remove, capture the wildcard and write elements that you've read from the list. And write elements that you've read from the list. I'm not sure what it means to capture the wildcard. You can see that the list is defined by question mark extend, wildcard extends natural numbers, not read-only in the strictest sense of the word, but you might think of it that way because you cannot store a new element or change an existing element in the list. So you can't modify elements in the list, and you can't add new elements in the list, where those new elements are not natural number, even numbers, but they're I don't really understand. Yeah, I really don't get it. I'm pretty lost here. That's it. That's all we got. Oh no. So list of integers is a subclass of a wildcard that extends integers, and a wildcard that extends integers is a that list is a subclass of a wildcard that extends a number, and then that's a subclass of the wildcard. And similarly, a list of numbers is a subclass of a wildcard that has a super of a number. So now this isn't the same thing as extending a number, right? Super number and extending number. This actually means that this is a this is something that it's not a wildcard that extends the number. It's a wildcard that is a parent of number. Yeah. So it's super of number, which means it's a parent of number. So naturally, since list of number, since number is number, then anything that's a parent of number, you can use that wildcard and say, okay, that now this list is now a parent of this list number. It's really confusing, but yeah, that's these are lower bounds, right? And then anything that's a super of number is also naturally going to be super of it. Now this is really confusing. So something that's a parent of number. So this is a class that's a parent of number. And then a class that's a parent of integer. So that's so confusing. So this integer, this is a class that is a subclass of integer. A subclass of integer is not going to be a parent of integer. It's the other way around. It's a class that extends integer. So the wildcard extends integer is actually a parent of integer, and the other way around. So these are upper bounds, right? It talks about this is actually the wildcard is a parent of something, right? That's why it's an upper bound. The lower bounds, the other way around, these are actually subclasses. So the wildcard is a parent of integer, and so that's obviously going to be a parent of the list integer. And this wildcard is a parent of number, which means also must be a parent of yeah. So the extends it means that the wildcard is a parent of number, and it extends subclasses number and subclasses integer. Am I understanding this correctly? I don't think I'm understanding this correctly. Because you subclass integer, because this subclass is integer. Integer is actually the parent class. So no. I'm so confused. Utterly confused. Okay, let's do lower bounded. Let's do wildcards. Question mark called the wildcard represents an unknown type. The wildcard can be used in a variety of situations as the type of a parameter, field, or local variable, sometimes as a return type, although it is better for program practice to be more specific. The wildcard is never used as a type argument for generic method invocation, a generic class instance creation, or a supertype. Excuse me, the following sections discuss wildcards in more detail, including upper bounded wildcards, lower bounded wildcards, and wildcard capture. Upper bounded wildcards. You can use upper bounded wildcard and upper bounded wildcard to relax the restrictions on a variable. For example, say you want to write a method that works on list integer, list double, and list number. Achieve this by using an upper bounded wildcard. To declare an upper bounded wildcard, use the wildcard character followed by the extends keyword. Okay, so extends is upper bounded, followed by its upper bound. Note that in this context, extends is used in a general sense to mean either extends as in classes or implements as in interfaces. Okay. To write the method that works on lists of number and the subtypes of number, such as integer, double, and float, you would specify list wildcard extends number. The term list number is more restrictive than list wildcard extends number because the former matches. So this works on anything that's a subtype of number. Former matches a list of type number only, whereas the latter matches a list of type number any of its subclasses. Oh, okay. So this wildcard extends number is any subclass of number. That's why it's an upper bound. And the other one is any super. Oh, okay, I get it now. It was so confusing before, but this. Okay, so super is a lower bound, and that means this works on any class that as a superclass of number. Any superclass of number. Obviously, list of number is going to be a subclass there, and then any superclass of integer. Number is going to be superclass is going to be a subclass of. So that's even more confusing. Which one's which? Which ones are superclasses of what? Well, there are more superclasses of integer, and all the superclasses of integer include superclasses of number. Yes, that's what I'm trying to say. So this is not actually a subclass, sort of a subset of all of those classes, and then these are subsets of all those classes. So it's more like a subset type of way to think about it. So this list integer is a subclass of the upper bound, which subclasses all the things that are all the subclasses of integer, which includes integer, and then naturally all the subclasses of number includes all of its subclasses, all the subclasses of number, also integer and all of its subclasses. So that would include list integer, and that would include this subset of all of the subsets of subclasses of integer, and then naturally the wildcard just includes everything. And then list of numbers is a subclass of all of the superclasses of number, including number. naturally, and then all the superclasses of number, including number, because it's confusing because all the superclasses of integer actually includes number and all of its superclasses because you're going the other direction. So this is actually a subclass of super integer of the lower bound, of the lower bounded wildcard, right? Because this includes all of the upper classes of number, and then because integer is a subclass or superclasses, because integer is a subclass of number, the classes that are superclasses of integer include all the superclass of number and all the superclasses of number and all the superclasses of integer, whatever they might be. And then naturally, again, all the superclasses are also this is a subclass of list of just wildcard. And then here, this is interesting too. So list number is a subclass of the wildcard lower bounded by, is it upper bound or lower bound? Upper bounded by number, right? Because it's number and all of its subclasses. So naturally, this is a subclass of that. And list integer is a subclass of the lower bounded wildcard, where the lower bound is integer and all the superclasses, right? So the lower bound and the upper bound is related to the superclass and the subclassing. So an upper bound means everything below, so all of the subclasses are included, bounded at that, extends number, right? Bounded at number, and then so extends meaning all the subclasses of the wildcard that are subclasses of number, including number, and then that's an upper bound, because you're going down the hierarchy for that set, and the lower bound means you go up the hierarchy. So up the hierarchy from integer gives you all of the classes that are superclasses of integer, including integer. So naturally, the wildcard of all. Now, what's interesting though is that the superclass of number, list of integer, is not a subclass of the all the superclasses of number, including number, because list of integer is not a number, nor is it's actually a subclass of number, not a superclass. So it's actually not a, and similarly in the other direction, list of number is not a subclass of the subclasses of integer, because it's actually a superclass of integer. So it's on the other side of that bound. So yeah, really interesting, but that's what's going on. Okay, I get it now. Took a while. All right, we probably don't need to. Oh, these are like the basics, returning a value. All right, we can close these things. So, well, you know what we'll do? We'll just come back tomorrow. I mean, I wasn't expecting to kind of take so much time. I don't know. Yeah, I kind of want to stop, I think, and just go to bed. I was thinking we could spend more time. Didn't really get a lot done today. Today is Thursday. Tomorrow's Friday. We can go over. I guess tomorrow I'll kind of wake up bright and early and get to working on things. Yeah, we definitely want. We want to use lambda expressions, right? So the is_odd function. I guess these need to be lambda expressions or use lambda expressions. I'm not really sure how I want to do this. Well, it returns an object, right? So we can do perform operation. We can say we can use a lambda expression here, I guess. Yeah, I guess so. I don't know. Let's see what happens when we do this. Just want to finish this. That was the reason why we started digging into the docs in the first place, documentation. Yeah, it seems software development really more than anything else. It's a lot of reading. Oh, it works. Oh, no kidding. Look at that. Okay. Neat. And what about this one? I don't know if we can do this, because this is a little bit more involved. How about that? Oh, it does work. Oh, look at that. Oh, neat. Oh, that's awesome. Not awesome. That's great. I gotta stop using the word awesome. Awesome is a word reserved for God. Truly. So I would not use the word awesome lightly. It means to strike fear into your heart. Being able to use lambda expressions doesn't strike fear into my heart. That's not at all the truth. That is great, though. I mean, that's quite a good. I like that. I like that a lot. That's what I can say. I like that a lot. Okay, let's try this now. Oh wow. I understand lambda expressions now in Java. They're quite different from what I'm used to, lambda expressions in C++. They're not that different, but they are different. Lambda expressions in C++ are like, I mean, they're basically just their own functions. They're pretty much just inline functions. Whereas lambda expressions in Java are a little more involved. They have a functional interface, and yeah, you just need a functional interface that has one abstract method, and then you can make lambda expressions out of it, and you can use whatever interface you want. But you just have to make an interface first. Whereas actually like I said, in C++, there's no interface that's required. You just write a function and you're on your way. And the interface, I think, actually kind of specifies the return types and the function signature. So you can kind of leave out a lot of detail. And you can use generics too if you wanted to. So that's interesting. Okay, neat. I like that a lot. Yeah, I think that was what I was supposed to do for this problem. Return, perform operation, return a lambda effectively. Okay. What's next? All right. We'll just leave this here. So, yeah, we got 6 questions left. We're almost done. That's great. Again, I thought we'd get a little bit further, but there was a lot of reading to do. Oh, a lot of reading to do. And I mean, how I went so far without reading language, just the language specifications, the language documentation. I don't know, man. I don't know. I don't know what to think or make of it all. I don't know. I don't know anymore. I don't know what to say. I don't even know. What was I even doing the past 6 years, 8 years, 10 years, what have you? Working the past 4 years. Actually working for pretty much all the years that I was at university. never thought struck me to just read like the language documentation. Could have done that for Python, Java, C++. I don't know. I don't know why I never did that. Did all kinds of other things. I never did that. Never bothered to do that. I don't know, man. I don't know. Huh. Well, no one told me to. And that's one thing. Which seems kind of weird. But, yeah. I mean, I had, like, the idea that I could or should do that at some point. But I didn't, like, I kind of didn't know. Like, I didn't have the context, you know? Like, the context is you're interviewing at different companies, and you're trying to get a job, and you're trying to actually work in the technology that they're working with. So you'd want to learn that language, you know, just read the documentation on that language that they're coding in. That would have been very valuable 10 years ago. Someone explained that to me. To do that, that would have saved me a lot of, or I would have been a lot more proficient in that language, and I could have done that for multiple languages way back when. I could do it now. I mean, I'll be way faster now, I think, reading those things. But I could have been doing that when I was 18, you know, 10 years ago. I don't know, man. I don't know. Instead, I actually was programming, trying to solve different math problems, and just kind of sitting and thinking about math problems for a long time, which was probably not the best use of my time. And I kept doing that. I still was doing that even when I was trying to solve the data structures and algorithms questions. Interesting. Excuse me. I don't know. I'm just going to say, look, God's in control, and everything that happens, you know, God's not surprised, and basically planned from the beginning what was supposed to happen. And that's it. You know, you kind of can't really get too hung up on these things. But yeah, I think I would have been a lot better at getting a job if I had a little more context of like what I should be studying and doing. I think I would have been a little bit better at finding employment a lot sooner, a lot more easily. Just for whatever reason, it's not how it went. Yeah, so many different things to explain that could have been explained, and they just were not. What I probably should have been focusing my time on. Yeah. The universities, they gave you classes for like all kinds of stuff, like stuff that's totally unrelated to your employment, and it's like, well, like I'm going to university to get a job. Like, why the heck are we learning all this other garbage? You can go learn those things after you have a job, after you're able to pay your bills. Then you can go learn these other things. Yeah, it seems really bad. Like a really, really ill-informed, misinformed, poor guidance, poorly planned, just a bad idea. It's like encouraging people to go to university for 4 to 6 years to learn things that are unrelated to their employment and not be able to get a job because they wasted their time basically either A, doing things that were unrelated to anything because they thought they had time because they thought that they were going to get a job once they had a degree, or which is actually most of what my time was spent doing was just things that I thought I was fine. I thought I got into school. I thought I was doing what I was supposed to do. I was lied to effectively. And then two, and B, working on things that are just not related to your job. Like, it's such an incredible waste of time. Oh man, wow. If I can go back in time and tell myself that, that would be so good. Yeah, that would have changed my life, quite frankly. My life is a lot harder now because of those things. I I mean, in some sense, it glorifies God because it shows me, like, yeah, this is what heathens will do to you. Like, the secular world will misguide you and mislead you in ways that will make you suicidal, quite frankly. But if you're a Christian, I mean, if I spent all that time just reading the Bible, one, I'd know the Bible, like, I'd have the whole thing memorized by now, and two, I probably would realize I needed a job, I needed to focus on things to get a job, and it would have been a lot more clear what to do, the path. So even though it's painful and upsetting and frustrating, all things considered, it also helps me to recognize that, yeah, all glory to God, praise God, I should have been following God from the beginning. So it, in some sense, actually heightens my view of God, having suffered, because I recognize how much better things would have been if I just followed God from the beginning. Don't bother going to school. You don't need that. You need money to start a family, not going to school to get a degree to quote unquote make more money, which you would have wasted all that time going to school. You could have been more directly approaching the problems here. Oh, this is interesting. MD5 considers MD5 to be cryptographically broken and unsuitable for further use. That's interesting. All right. Anyway, so yeah, we got a lot of reading to do, and we have obviously reconsidering our life choices, right? Reassessing our life choices. So let me go. I'll talk to you soon. I think maybe I should turn on this volume here because I could see, like, when I speak loudly, if I laugh, haha, right, it pops up here. So I'm sorry if that's a little too loud. Yeah, if I'm yelling at all, yes, I should probably keep it down here, a lot lower. Yeah, it's definitely much better. I think that's where it should be. Anyway, I'm gonna go. So thank you all for watching. Talk to you soon. Have a good rest of your day or your night. Tomorrow, I think I'm just gonna go, like, hang out and go to bed. Tomorrow, pretty much we'll just keep going. Keep reading the Javadocs and finish the last 6 problems on Hackerrank, and then go for the Java certification. And that's that. I should probably have that done pretty early in the morning tomorrow. And then after that, we'll pretty much do the same thing for Ruby. There's a 10 days of JavaScript, which is like a similar kind of thing that we can do also. We'll also read the docs for Ruby, read the docs for JavaScript, read the documentation probably for Ruby on Rails, read the documentation for React again. And then yeah, and then get the certification. I probably want to do the Angular certification too. Read the documentation for Angular, do those exercises on Hackerrank, and then also get the certification on Hackerrank for Angular. And so I get Angular, I can get Java, I can get JavaScript. JavaScript doesn't have a certification on Hackerrank. And then from there, I don't know. I don't know what I'm gonna do after that, but that's the plan for, like, the next 3 days, tomorrow and Saturday and Sunday, and try to go through learning all these things and solving all these problems as quickly as I can. Should be relatively fast, but yeah, I don't know, man. I don't know what to say. Like, glory to God, and the secular world is just gonna fail you horrendously. Just not gonna point you in the right direction at all. Just so selfish, and that's so upsetting. That's so frustrating. It's really just upsetting. All right, I'm gonna go. Thank you for watching. Talk to you soon. Take care.